have all the stuff unlocked. So same map. Hey, Astro. Oh, we can go to a different map. I don't know, man. Are there other maps like that that have a lot of different cool features? Because the Eastern Europe Small Hills map kind of sucked. That was a really difficult map because there wasn't anything useful anywhere. But I'm with Bremo. Pacific Drive is right up your alley. Can we take a break and play Pacific Drive? Are you doing NSF for this lander? No. You can do a random map, then tweak the features on it. All right, we'll look into it. The jury's still out. Jury's still out on what map. I do like that map. It would be actually kind of cool to start that map at a different location than where Spaghetzov is, but one thing about that map is that there's no other NATO portals. Ilios is the only one. That's the only connection to NATO that you have, so yeah, Pacific Drive with the Route 154 emote. Yeah, it's hell. I don't know. We'll find time to play Pacific Drive, dudes. I'm doing NASA Spaceflight Live tomorrow, so I think, yeah. Well, there's not enough time. There's not enough time in the damn day, dudes. You can create other portals, though? Really? How do you do that? Nice sig you got there. Thank you. Anyway, we'll talk about it more when I'm a little more confident than I am right now. Okie dokie. Boats and stuff. Bro, I feel that lack of time in the day. Yep. Hey, 415. All right, guys, here we go. No sound. Oh, dude. Couldn't have timed that better. All right, let's time warp up. So we're going to start the IM-1. This is our coverage of the IM-1 coverage of the lunar landing for Intuitive Machines. Let's just make sure we're caught up.
It's an autonomous Nova-C-class lunar lander named Odysseus. Lunar lander arrived at Kennedy Space Center in Florida back in December. Since then, teams have been integrating the spacecraft to Falcon 9's second stage in preparation for launch.
So IM-1 and Odysseus lunar lander.
Falcon 9 has successfully lifted off from Pad 39A at Kennedy Space Center. An incredible sight to see.
Dude, that's awesome.
Odysseus lunar lander separation.
So cool.
confirmed.
Our Nova-C lunar lander has successfully separated from the second stage of the launch vehicle, autonomously commissioned, and made first communications contact with Nova Control.
Our approach for landing is actually very similar to what Apollo did, which should be no surprise because the physics are very much the same.
Let's honor this momentous milestone and prepare for the challenges and triumphs that await us on our lunar journey.
Discovery, go at throttle.
Hey, Postal.
You're taking a live look into Intuitive Machines' Nova Control in Houston, Texas, where
Thanks,
flight
man.
controllers are
Thanks for the
preparing
5.
to start the
Moto,
landing
thanks for the
sequence
27.
the IM-1 mission. Our mission and activity directors are sitting closest to the large monitor inside Nova Control, and they're supported by 10 additional flight
Intuitive
controllers
Machines?
Surrounding the Circular Mission Operations Center.
An aerospace company.
Good afternoon, and welcome to our coverage of the descent and landing
Hey,
of the
Gary's
IM-1
there.
mission.
All right.
I'm Josh Marshall, communication. Additional flight controllers surrounding the Circular Mission Operations Center. Good afternoon, and welcome to our coverage of the descent and landing of the IM-1 mission. I'm Josh Marshall, Communications Director of Intuitive Machines.
And I'm Gary Jordan with NASA Communications. This mission is one of the first under a task order with NASA's Commercial Lunar Payload Services Initiative. Under Artemis, we're returning to the moon to conduct
Come on,
scientific
speed up.
discoveries and technological advancements. And this mission with Intuitive Machines is helping
Yeah, Conical, I'm with you.
us to get there.
And Gary and I are at Intuitive Machines' facility here in Houston, just down the street from NASA's Johnson Space Center. Right now, inside Nova Control, flight controllers are monitoring our Nova C-class lunar lander named Odysseus ahead of its autonomous landing sequence that begins with powered descent initiation at 5:11 p.m. Central Time for a landing time at 5:24 p.m. Central. Right now, they're keeping an eye on the room's situational awareness tool called the Viz, which you can see on your screen now. The Viz is casted onto a large television in the front of Mission Control, so the activity director and the mission director can have the best view, Gary.
And the Viz is an animation representing real-time telemetry data feeding into Nova Control. Nova Control receives the data, runs it through Unreal Engine 5, and generates a visualization of the data. It's a useful tool for situational awareness and keeping track of what flight controllers expect Nova C is doing in space.
So, yeah,
the white line points to the moon.
Hey!
The blue line
I'm
is
over
the
here.
past
No, I'm over
and
here.
ended trajectory. The yellow and red lines
Unity
are pointing
is
towards
better
the
at
sun
Capap.
and Earth, respectively.
Okay.
The different color cones you see at the top are the antenna arrays used for line-of-sight communication back to Earth. We'll show the
I'm gonna boost the volume here, guys. So if you have your volume turned up, I'm gonna turn it up. Just
final moments before landing, the most reliable spacecraft data will be relayed through Nova Control audio loops.
And we're starting our coverage later than expected today as flight controllers continue to assess Nova C's trajectory, guidance, navigation, and control. Nova C maintained a low lunar orbit, but is in a slightly more elliptical shape. Last night, flight controllers performed a lunar correction maneuver burn to adjust the lander's orbit. This burn kept Nova C on a trajectory to land in Malapert A, but moved our landing time estimates earlier by about an hour. Then today, flight controllers chose to exercise an additional orbit before starting the IM-1 mission landing sequence. This decision brought us to now, projecting a landing time of 17:24 Central Time. Intuitive Machines made the decision to reassign the primary navigation sensors from Odysseus's laser range-finding system to use the sensors on NASA's navigation Doppler LiDAR.
This is a dynamic situation, and we'll update you later in the broadcast. Intuitive Machines still intends to land in the optimum lighting window, and the lunar correction maneuver performed last night eliminated the need for the planned 10-second deorbit initiation burn, which would have brought Nova C from low lunar orbit into the descent phase.
Resub-sequence is underway.
Nova C's current trajectory has it continuing to decrease its altitude over the next hour until the braking burn called powered descent initiation.
Again, the landing time is expected at 5:24 p.m. Central Standard Time, 6:24 p.m. Eastern. The countdown clock at the top of your screen is counting down to the time that we expect to remove, and we expect to remove the countdown clock approximately 2 minutes before the landing opportunity. Getting to this moment, Gary, has been
Dre, what's good, man?
And it's lasted about 7 days so far since liftoff.
Best mission control I've ever seen, Alleviate.
At NASA's Kennedy Space Center.
Josh, the commentator over there, when they launched it last week, was saying that their mission control is inspired from the bridge of the Enterprise. Which is, all right. What do I always say, man? I always say, you know, if you're a private spaceflight company, bro, frick the Land Center vibe, dude. We need consoles. It needs to look cool. You're selling the idea of space, so put the computers in a console desk and make it look cool. But also, you could do that too.
This was called the commissioning maneuver.
Which Enterprise?
It was a full-thrust main-stage engine burn with a throttle
I'd say
down
Enterprise
profile
A, but it's just
necessary
me.
to land on the
B-Money
moon.
and Astro,
Over
thank
the
you for
last
the
24
resubs, dudes.
hours, Odysseus has maintained its trajectory in low lunar orbit, waiting for suitable
I'm
landing conditions to begin its autonomous descent to Malapert A, the designated landing site for the IM-1 mission near the south pole of the moon.
I'm a bit late, but I didn't know that Falcon 9 had the Delta V to shoot something to lunar orbit. Falcon 9 put the IM-1 lander on a trans-lunar injection, or TLI. It was a high-energy transfer burn. I think separation velocity was somewhere in the ballpark of 35,000 kph, which is, that's trans-lunar injection velocity. The lander itself did the circularization burn around the moon 2 days ago, and now they're lowering the orbit, as Josh said. But yeah, the lander is not too incredibly heavy. It's not high. Well, it has nothing to do with it. It's not high mass, dude. It's I think it's 4 tons or something. For Falcon 9, 4 tons is nothing. You could shoot a 4-ton object on translunar injection. That's no big deal. What you can't do is do that with 12 tons or 13 tons. That's like a Dragon capsule. And that all has to do with the rocket equation, with Tsiolkovsky's rocket equation. Well, and what does that mean in plain English? Well, the plain English way of saying it is that the more rocket you have on your rocket and the less fuel you have on your rocket means your rocket is not going to go as far. With a low mass payload for Falcon 9, you have less rocket and payload on your rocket and the same amount of fuel as any other particular mission, right? So, you have less rocket on your rocket and more fuel on your rocket. You'll go further. You can go further in space. You can accelerate faster. Accelerate to a higher speed. That's the right way of saying it. But yeah, man. Also, you know, Falcon 9 is a workhorse. It's a monster. I always say that Falcon 9 is basically doing what they wanted the space shuttle to do. Just routine access. You know? Really wish we'd done this with the space shuttle, but after that program ended, I'm just happy someone's doing it. You know what I mean? I'll take Falcon 9 launching every day. That's fine. That's cool.
Greater plan,
yeah, I'm good with that. I don't know about you.
Leah
I'm good with that.
Cheshire, who's just down the hall. Hey, Leah.
Thanks, Gary. I'm here with Joel Kearns, NASA's Deputy Associate Administrator for
6 months in advance from Conical.
Oh, thank you, man. It's great to be here on landing day, which is the culmination of about 5 years of work by Intuitive Machines Corporation.
Yeah, we're really excited, and we want to know a little bit more about NASA's goals for the CLIPS initiative.
Okay. So, most basically what we want to do is we want to have American companies take NASA equipment and scientific investigations all the way to the surface of the moon and not have to have NASA do that ourselves. NASA is really good at doing robotic space science missions, whether that's the James Webb Space Telescope or it's the Mars rovers. But when we knew about 5 or 6 years ago that we would start going to the moon to do science and exploration investigations, we knew we'd be going back every year, so we turned to industry to see if they could actually take us to the moon instead of us having to do it ourselves. And that's how we came up with commercial lunar payload services. There's 3 objectives for commercial lunar payload services, or CLIPS. One is that we want to do great science on the moon. The second is we want to test out technology and engineering for future human exploration in Artemis. And the third is we want to generate a group of companies that are highly skilled in doing these robotic lunar landings so that we can use them as part of our Artemis initiative.
49 months.
Let's talk about that a little bit more. How is CLIPS beneficial to the Artemis campaign?
Well, a number of different ways. For example, we will do science at the South Pole with our astronauts in Artemis and also with robotic explorers. They'll be brought down on CLIPS. But we're also going to use these robotic landings, these commercial robotic landings, to do science at places where we won't initially send astronauts. We can use them, for example, this Intuitive Machine mission that's going on today that'll land in the South Pole region will be one of the first forays into the South Pole to actually look at the environmental conditions to a place we're going to be sending our astronauts.
Charles, thanks for the gift.
That is, what type of dust or dirt is there? How hot or cold does it get? What's the radiation environment? These are all things you'd really like to know before you send the first human explorers. I'd also say that in the future, when we are flying humans to the moon as part of Artemis, we can use commercial services like CLIPS to pre-stage equipment or other cargo so that they're waiting for the astronaut explorers when they land.
We should do that.
An entirely new
we should do that.
That uses a
That's a good
privately
idea.
developed
Analyzer.
What are some of the
Tier 2, 31 months.
What are some of the most important takeaways on risks but also benefits of a model like this?
So when industry came to NASA about 6 years ago and said, we could do this for you as a service, what they said was they thought it would be less expensive than if we did it ourselves, that they could do it faster than we could set up to do it, and that they could do it more frequently, that they could do more than one mission every year or two. And so far we've seen is that looks like that's going to be true. What we're waiting to see, such as with the mission today, is can they actually do this incredibly difficult thing? Can they really land on the surface of the moon robotically? This is something which is extremely challenging and difficult to do. The moon has no air. You can't use parachutes or wings to slow down. You have to, in effect, ride a rocket engine all the way from orbital speed, thousands of miles per hour, all the way down to a very soft touchdown speed to land in this place, which is very rough, pretty rugged, in really unusual lighting and communication conditions. So this is not an easy thing we have asked these companies to do, but if they're successful, the upside for American exploration is just so great, we have to try it.
Yeah, absolutely. Those are important distinctions. And thank you so much for joining us here today, Joel.
These are actually
With that,
helping.
we're going to toss it back to Josh and Gary to preview the landing sequence.
Gary?
Thanks, Leah. We're following along with Novacy's descent toward the lunar surface. The lander is continuing to decrease its altitude until the powered descent initiation, an 11-minute braking burn that sets Novacy up for the final moments prior to touchdown. That time of ignition for PDI, or powered descent initiation, is 5:11 p.m. Central Time, 6:11 p.m. Eastern. The entire landing sequence is autonomous, meaning the lander is in control of every milestone required for a lunar landing opportunity, Gary.
And completing a soft touchdown comes with challenges unique to, say, landing on the Earth or Mars, because there's no atmosphere.
Gary, it's an entirely different playbook as we've seen this dynamic situation play out today. Let's take a look at the IM-1 mission's complete trajectory approach as of launch.
This is happening right now, Charles.
The Intuitive Machines IM-1 mission is sending commercial and NASA payloads to the lunar South Pole region on an uncrewed robotic Nova-C-class lunar lander called Odysseus.
The lander is the tip of the iceberg,
and
what's below that is the full program that is on a miniature scale, very similar to what the Apollo program had.
The IM-1 flight path mirrors the historical achievements of Apollo 2.
You guys want to hear something nuts? This is a Methalox lander, fully cryogenic. Everybody who said we can't use fully cryogenic propellants around the moon is in shambles right now. It's freaking Methalox lander. Can you believe that?
Houston firing the lander's 3D
How does it stay cold?
Liquid methane and liquid oxygen engine to
insulated
make
tanks,
small
dude.
adjustments.
Heavy insulated tanks. That's what all that gold stuff is on the lander.
This particular coordinate system
Buffalo?
is called the B-plane.
Yeah, we're good, man. We're hopefully going to get a lunar landing today.
Kind of like the backboard of a basketball goal. And you basically know when you shoot hoops that if you can get the basketball in the square on that backboard, it's going to go in. And the B-plane for astrodynamicists is very much the same thing.
With the B-plane on target, Odysseus is prepped for a critical autonomous maneuver on the moon's far side.
About an hour hooded, yep.
This critical burn maneuver is completed in the blind.
Boil off is a myth.
Direct
With enough
communications
insulation,
back to
you
Nova
can mitigate
Control
it.
in Houston.
Once we get around the
Sup,
moon,
Slider?
we have on the day side of the moon, the sun heating us from one side and reflected infrared light off the bright moon warming us on the other.
Yep.
Then we plunge into night, and now we're cold on both sides. It's very tough.
About
That's a
an
hard
hour
thermal
before
problem to
landing,
solve,
flight
for
controllers
sure.
command descent orbit insertion, or DOI. This is a main engine firing to slow
Absolutely,
the spacecraft
Shardies.
so its altitude drops
Bonjour,
from
mon
100
ami.
kilometers to about 10 kilometers
ça
above
va?
the lunar surface. After DOI, Odysseus coasts for about an hour before starting its final approach.
And then we reach a point called powered descent initiation. The guidance system on board makes the decision to activate the main engine at very close to full power.
Cameras and lasers are feeding information to the lander's navigation algorithms, which provide guidance, navigation, and control. With a safe
GNC.
site identified, Odysseus enters a 3 meter per second descent.
Is
then
active
down to 1
refrigeration
meter
an
per
option?
second
Sure,
for
but
the
where are you
last
going to put the
10
heat,
meters
Jonas?
to the lunar
Yeah,
surface.
absolutely. You're
Now,
going to need
the
radiators
lander
to
is
do that, and
using
it complicates
an
the
inertial
design.
measurement unit, which is similar to a human inner ear that senses rotation and acceleration. Flight controllers expect about a 15-second delay before confirming the ultimate milestone, softly landing on the surface of the moon.
And I can tell you just from doing our simulations, that's the longest 15 seconds you'll ever experience as you wait for the final light to turn green to indicate that you've landed on the moon.
Approximately 12 minutes before our landing opportunity, we are going to show this
It might actually
animation
come
of the
back
landing
around, Jose.
sequence to
It's in the
describe
night
the
right
lander's
now.
autonomous operations, starting with powered descent initiation, or PDI.
Why do I have a toothpick? Brimo gave them to me. They have they're laced with caffeine. I'm trying to stay awake, Seacrock, and I've probably gotten maybe 10 hours of sleep this week total. I'm working on a lot of different things right now. So these are keeping me going right now. I started to get super tired when we were playing workers, but yep, 106 out. Bruh, I'm good, man. It's good to work hard. It's very fulfilling. How many landers failed a moon landing recently? Does Slim count? So, Hosen, you asked about Slim. Slim is in the lunar night right now. They're going to see, even though the solar panels are facing the wrong direction, they're going to see if when the sun comes up, if they'll get the lander back.
Its first autonomous spacecraft. NOVA stands for new, and C is the
I'm going to take a break after the landing.
For 100, the lander's approximate payload capacity. With that, let's learn more about the NOVA C-class lunar lander.
This IM-1 mission lander is named Odysseus. The name was nominated by assembly, integration, and test engineer Mario Romero
Chris, I know.
after the Odyssey and its epic voyage across the daunting, wine-dark sea. Including landing gear, Odysseus is 4.6 meters wide, and with its top deck solar array, it's 4.3 meters in height. It's a taller design that accommodates payloads
about
and
15
the lunar
feet.
South Pole lighting conditions. Its hull diameter is 1.6 meters, with payloads affixed to the entire exterior of the lander, making its total payload capacity approximately 130 kilograms.
Okay.
The lander weighs 675 kilograms, but packs on weight when loaded with fuel. Odysseus uses composite helium tanks to pressurize its liquid methane and liquid oxygen main engine that can throttle down to perform its final descent to the lunar surface in one continuous burn.
If anything, some of the projects that I'm working on will end up with me
IM-1 mission is
more.
supported by NASA's Commercial Lunar Payload Services Initiative, which allows rapid acquisition of lunar delivery services from American companies. The instruments on board advance capabilities for science, exploration, and the commercial development of the moon. Commercial companies were challenged to come up with their own way to design and fabricate a lunar lander and conduct operations. For this commercial mission, Intuitive Machines elected to support the communications between the spacecraft and NOVA Control through its own private ground-based network. And it's not the first time Intuitive Machines used this network in deep space.
Well, that's right, Gary. NASA worked with Intuitive Machines to perform technology demonstration of this capability on NASA's Artemis 1 mission, which helped us verify the network for operational use during this CLIPS mission. The Lunar Data Network, or LDN, uses ground-based networks to communicate into deep space, so we could lose signal while Nova C is on the far side of the moon. However, the trajectory of the lander's low lunar orbit does allow for near continuous line of sight with Earth and ground station coverage. Let's head over to NASA's Leah Cheshire to learn more about this network. Leah.
Thanks so much, and I am here now with Trent Martin, the Intuitive Machines Senior Vice President of Space Systems. Thanks for joining us, Trent.
Thanks.
We're here to talk a little bit about the Lunar Data Network. This is a private deep space network, belongs to Intuitive Machines. How does it differ to have this commercially available space network, and how is that different from NASA's Deep Space Network?
So when we first got onto the Commercial Lunar Payload Services contract, we were trying to find a way that we could get our data from our landers back to the Earth. We were worried that the Deep Space Network, which is often oversubscribed, particularly with James Webb Space Telescope now, that we would have limited time. So what we did was we created a network of large dishes across the planet that allow us to take our data from the moon and deliver it down to the Earth.
And we initially tested this out during the Artemis 1 mission. So how did Intuitive Machines work that out?
Yes, we worked a reimbursable Space Act agreement with NASA to allow us to test our network not only with Artemis at 430,000 kilometers, but also with the Lunar Reconnaissance Orbiter, as well as the GOES satellite.
Okay, and what are the goals overall for Intuitive Machines? How do you want to expand this LDN coverage?
So we believe that as the market expands at lunar distance, many people will need the capability to send data back, particularly if you're operating spacecraft on the backside of the moon. You need to be able to have a relay satellite. So we're going to put relay satellites in orbit to complement our ground-based systems, which are, again, large dishes all over the world. And by doing that, we'll be able to hopefully create a market for that data system from lunar space.
Hear that, Death?
Okay. Is there anything else that you want to share that has gone into the development of this network?
It's really exciting. We've actually been using it this week once we launched Odysseus into space, and we're taking it to the moon. We've been using this network that we tested with NASA systems
about an hour out
for the whole week, and it's been incredible to see it work and see it in action. We have a long ways to go with it. We need to add additional satellites to the system so that we can relay data back from the moon. But we think it is the future of humanity in lunar space.
Thanks so much. It's really exciting to see this in action. And we are just minutes away from acquisition of signal to confirm deorbit insertion. So we're going to send it back over to Josh and Gary to follow along with the operations.
Thanks, Leah. That Lunar Data Network information feeds into Nova Control's communications and ground network console screens. It's just one of many different screens that are used by the flight controllers, and we want to bring you closer into the mission and into our Mission Operations Center. Let's take a look at what flight controller teams are seeing now. This particular screen is called the Deorbit Descent and Landing, or DDL screen.
My left ear loves this.
This is primarily used by the mission director and landing system experts. It's used primarily while Nova-C orbits the moon and through landing. The top right images of the moon are called the lunar tactical view. When the dots turn red, the lander is on the far side of the moon, and green is on the near side.
This is why satellites take up a lot of bandwidth, all of this.
Each dot representing 10 minutes of elapsed time. The acceleration sensed portion of the screen shows raw acceleration values from Nova-C's inertial measurement unit. This is used a lot during burn maneuvers and is a more robust way of measuring acceleration
multi-axial IMUs. Very nice. No, I'm not making up words.
Lost data. Finally, the column on the right is a received, accepted, edited, and failed pre-checked, or RAFE chart for short. When each of these lines are on top of each other, that's a good indication that Nova-C's navigation system is in good health. That's because every measurement Nova-C makes must be received, accepted, edited, or failed pre-check. The failure is a possible outlier of data that the lander's computer automatically knows is bad information. Collectively, the DDL screen is one of many data displays that flight controllers are monitoring to successfully navigate Nova-C to the lunar surface.
So, that last thing that he showed, the REAF, that is a visual algorithmic landing system. So, there's a door there? Is the door curved? Sorry. Anyway, so, okay, if that doesn't make any sense to you, well, there's Odysseus is using a what's called a relative navigation system. Relative navigation systems are a computer-based system that basically works on the logic principle of how a human's eyes and brain would navigate.
Discovery, go at
so think about it like this. You're flying in a plane. For the pilots, you're flying VFR flight rules, okay? Where's the runway? There's the runway. Runway's over there. I'm going to turn, so the runway is now in front of me because I want to get lined up with the runway. Am I lined up with the runway? Basically, you're looking out the windows, and you make corrective commands based off of what you see. A relative navigation system is doing exactly that. That's why they're checking the data against itself. That's where the algorithmic portion of this comes in. They're checking the data against multiple sources. Now, what are they using for relative navigation? They're using cameras, obviously. Relative navigation uses visuals, just like you'd look out the window on an airplane, right? But there are also optical or laser rangefinders built in to the design. The laser rangefinders are shining light down on the surface, and they're extrapolating altitude off the surface based off of how bright the reflection is from the light. So all those components are being fed into the computer, and they're doing it in double redundancy. So they're checking against themselves. That's where the algorithm comes in. That's why they have all the different relative navigation. That's what all those different things were. They're multiple inputs. Multiple inputs from the laser rangefinder, from the inertial measuring unit, from the cameras. They're all being inputted into the flight control algorithm. That's what that window, that DDL that he was talking about, that's what all that data is.
Ranging, which is a measurement of the distance between the orbiting or landing spacecraft
to
the reflector on the lander. LRA is a passive optical instrument that will function as a permanent location marker on the moon for decades to come.
This is a little mirror that's aiming at you all the time, regardless which way you're looking.
Those are those laser rangefinders.
My name is Xiaoli Sang. I'm a LiDAR instrument scientist.
Cool.
It's a small retroreflector mounted on an aluminum shell on the intuitive machine landers. When you shine laser on it, it reflects right back at you. The purpose is to have a precise fiducial marker on the lander. It serves as a landmark for future missions if you want to go back and land it there.
That's a beacon for future laser rangefinders that mark the location. So
Stereo
other
cameras for
relative navigation systems should be able to come in and use that as a ping.
4 cameras to capture stereo and still image data of the dust plume created by the lander's engine.
This is awesome.
From when it
Listen to
begins
Gary.
its descent to the lunar surface, all the way down through engine shutoff.
SCALPS is an array of small cameras that will be placed around the base of a lunar lander and collect imagery during the descent and landing of the vehicle. Using a technique called stereophotogrammetry, we can use those images to reconstruct a 3D shape of the ground. As the lander comes down, its hot engine plumes will interact with the surface. Our cameras will begin acquiring images from before this interaction begins until after the vehicle has landed on the surface. The SCALPS cameras will specifically be looking at the overall crater formation and erosion of the ground due to the rocket plumes. The final stereo images, which will be stored on a small onboard data storage unit, will be transferred to the lander and then downlinked to Earth, where we can use them to reconstruct the overall erosion volume and shape
in 3D.
The ground. With the Artemis program, we plan to establish a sustained lunar exploration and try to land multiple payloads in close proximity to one another. SCALPS data will be a critical part of understanding these phenomena and improving our computational models to inform these future landings.
They're going to use those 4 cameras to be able to reconstruct how the dirt moves around in a three-dimensional model.
Or RFMG
really
is
cool.
A fuel gauge used to measure the amount of propellant in spacecraft tanks in a low-gravity space environment. Using sensor technology, RFMG will measure the amount or mass of cryogenic propellant in Nova-C's fuel and oxidizer tanks, providing data that can help predict fuel usage on future missions.
It's a fuel gauge.
I'm Greg Zimmerly, Principal Investigator for the Radio
gauge.
Frequency Mass Gauge Payload. This instrument is a space-age fuel gauge. We're going to use it to measure the amount of cryogenic propellant in the Intuitive Machines Nova-C lander propellant tanks. These propellants are very cold. They're at about minus 300 degrees Fahrenheit. Now we're integrating the instrument onto an actual lunar lander. Future lunar missions, like those in the Artemis program, will likely also use cryogenic propellants and have to store those propellants in space for long periods of time. So having an instrument like this that can measure the propellant in the tanks in low gravity will help future lunar missions know how much fuel is in the tank at all times.
Now we'll discuss 2 more NASA payloads, Navigation Doppler LiDAR, or NDL, and the Lunar Node 1, or LN1, later during our broadcast. We'll have a special guest later in the broadcast to talk NDL upon its activation during descent. And Josh, we did get word that some of the processing of the optical images from NDL are already performing. They did some checks, and they're performing very well. Now, a common theme you'll find among the NASA payloads on IM-1 is helping to demonstrate technologies and our understanding of the lunar landscape that could very well improve operations for landing on the moon in the future.
Asking the right question.
From understanding the environment to precision sensors to literal beacons, the technology on IM-1 will help guide technologies and operations for future lunar exploration.
And Gary, with CLIPS as a springboard of innovation, Intuitive Machines designed and developed its complete lunar program to help support CLIPS and carry out the essential part of that directive, which included calling for the commercial development of the moon. Back in 2018, the U.S. government declared the moon of strategic interest. At that time, few companies and institutions were working on payloads designed for the moon because no one had been to the lunar surface in over 50 years. Gary, in the time it takes to get an undergraduate degree, 6 commercial entities created payloads for the IM-1 mission. We'll view all of them as pioneers helping shape this brand new lunar economy.
And Josh, a true lunar economy should not have just NASA as a sole customer. NASA's CLIPS initiative encourages a model where NASA is just one of many customers. And this is an important element to ensure that this model of transporting incredible science and technology instruments to the lunar surface is a sustainable and robust one.
Well, it's important, and Gary, it's also promising in this situation. The commercial interest for delivering science and technology demonstrations continues to grow. As of our 3rd planned mission, we're seeing more and more non-CLIPS payloads from both domestic and international companies and institutions which are driving us towards a future, maybe completely commercial mission to the moon, possibly as soon as our 4th mission.
Well, even on IM-1, there is a variety of unique commercial payloads. It's a good snapshot of out-of-the-box ways to think about what the moon can offer.
Well, that's part of the challenge beyond just creating the capability to land on the moon safely. We had to look toward a new emerging ideas and find innovative ways that may add value on Earth and spaceflight. Let's learn a little bit more about those payloads and the lunar lander attempting to make history.
Why would financial companies be interested in payloads on the moon?
Nova-C was our version of a liquid oxygen, liquid methane lander.
Long story short, Jim, if NASA is interested in going back to the moon, well, NASA pays pretty damn good. Just saying.
And liquid oxygen in 2018 on an airstrip at Ellington Airport in Houston, Texas.
We didn't have enough money for a facility with blast walls and water suppression or water deluge, so we had to test outside in the environment of Houston, where the temperature is about 100 degrees and the humidity is like the same, and we have an 18-hour day rolling out to the runway. It was brutal, dude. But we did.
Look at that thing, dude! Look at that thing.
Data we needed to
see it wiggle around.
Designed, manufactured, and controlled in space by Intuitive Machines, Nova-C's structure is primarily carbon composite.
We needed to build the lightest weight structure we could. That meant honeycomb aluminum core with composite face sheets, composite struts, and most importantly, linerless composite propellant tank. Man, what a challenge that was.
Between the engine, carbon composites, software, and electronics required to build a Nova-C lunar lander, it took an incredible amount of touch labor to get to the launch pad.
I bet.
We worked very closely with San Jacinto Community College
to
create a certification course for technicians, where they would take these certifications. We then, at Intuitive Machines, would give them an internship and test them out in the workplace. And anyone that showed the aptitude to be a really good technician, we hired on the spot.
Nearly all of the lunar lander's payloads are mounted to its exterior, including 6 NASA-provided payloads that will help lay the foundation for Artemis missions.
Those are the relative navigation
Aeronautical
cameras.
University's EagleCam, designed to deploy off Nova-C before landing to take third-person perspective images. The International Lunar Observatory Association's camera system mounted at exact angles that could capture images of the Milky Way from the lunar surface. A data technology demonstration
I really want that.
And Omni Heat Infinity.
Please work.
Sportswear's thermal reflective insulation used in many of their outdoor products will help protect Nova-C from extreme temperatures in space.
They've got brilliant ideas, and if we can help facilitate those startups to help build this economy, I think that raises all boats. And
carbon composites mean carbon fiber with some other
transportation leg
metal
to the moon.
or something.
We're happy to accommodate.
It's carbon fiber with other things. That's what carbon composite is. Smoke.
Now, the lander and our payload customers require command and control in space. Intuitive Machines' Mission Operations Center provides both of those elements. It's called Nova Control, Nova being the name of our lunar lander class, and Control being the nerve center of our entire lunar program. Its unique circular design fosters a collaborative environment where flight controllers and customers may make agile decisions. Let's take a live look.
Yeah, and inside that flight control room, Josh, it's important to note that these are not the only teams that have been in this room over the past 7 days. This is staffed 24/7 inside in Nova Control here. There's red, white, and blue teams that support this mission.
Gary, the mission required 24/7 operations. We're somewhere in between the 7th and 8th day. This has been 3 teams, red, white, and blue, working 8-hour shifts, which really turned into just about everybody working 12-hour shifts each. In addition, there's another team, the gold team, that's running problems and solving solutions that are coming up in the future. And at this moment, we talked about this being a dynamic situation, using 2 of NDL's lasers to feed into our HRN and TRN cameras to provide a landing solution. Every asset available out of all of these teams is on hand right now to solve these intractable problems and take the best shot at the moon we possibly can.
It really took a team to solve some of these. As you mentioned, a dynamic situation.
Yes,
now, you talked about the design of this room.
Yes, human fart cave. The lander is supposed to land where Artemis will be landing. Yeah, they're targeting the South Pole. And one of the secondary science missions on this is a laser rangefinder that's on the top of the lander that other spacecraft in the future could use to ping a laser off of and hone in on the lander and land next to it. So yeah, oh yeah, this mission is in support of the Artemis program. This is an Artemis mission technically. Very similar to how surveyor missions during the Apollo program supported the Apollo program. Surveyor, Ranger, those are very important missions. And just like the Apollo program, on Apollo 12, I said this a little bit earlier in the stream, but if you guys don't know, Surveyor 3, the third probe that JPL sent to the moon in 1966, landed it there. Apollo 12, second mission to the lunar surface, landed next to it. And Al Bean and Pete Conrad went and took parts off of that lander, put it in the LEM, and brought them home. Pretty cool, huh? That's what these are going to be used for. The Commercial Lunar Payload Services program is the precursor missions to human spaceflight out onto the lunar surface. Pretty awesome. Pretty cool to see it ramp up like this.
Thanks so much, and I am now here with
How many
Ben
toothpicks have you gone through?
Machines Chief Scientist to talk about Malapert
You don't want to
A.
know.
Thank you so much for joining us, Ben.
It's great to be here.
Now tell me a little bit about this landing site. Why was it chosen? What sets it apart?
So the most important factor when selecting the landing site was to find a good, safe site for Odysseus to land. And we're landing in highland terrain near the poles, and that was a fun challenge for the team. But we think we found a good, large, safe area free of boulders and craters.
Yes, dogs.
The other key factor was to try and land in the south polar region of the moon. If you know, NASA through the Artemis program with their international partners will be sending humans to the moon in this decade. So the goal was to find somewhere in the south polar region that was large and safe, and we sort of think just outside the rim of Malapert is sort of a Goldilocks location that will allow all the payloads to get the data that they want to get.
And you talked for just a second about that lunar highland material. That's what we believe Malapert A to be composed of. What is really interesting about the lunar highlands?
So if you look at the moon, you will see bright and dark regions, and the dark regions are lunar mare, which are old volcanic flows. The bright regions are mountains, are the highlands, which actually represent the original 4.5 billion year crust of the moon. So they're scientifically very interesting. They're also the same geology that the crew will visit. And so we want to go and get the first data of the highlands near the poles. And so we have one of our instruments, for example, is SCALPS, and NASA likes its acronym. So it's the stereo camera for lunar plume studies. And so that camera, which is 4 video cameras, will image the dust of the highland terrain right before we land, and so we will learn how it behaves as landers come down. So as we start to put multiple things near the poles, we know how far away we have to land.
Thanks for the 5-pack, man.
And
I appreciate it.
We know that there are some interesting conditions for these areas in the lunar South Pole. That can be lighting, that can be communications, terrain itself. So what can we expect at Malapert A?
So yeah, as you get very close to the poles, the lighting and communications becomes very challenging. And so for IM-1, we've gone to about 10 degrees, about 300 kilometers from the pole. And we think that's a good location because it's the closest to the pole that anyone's landed. But for example, we've chosen a site where you can see the Earth all the time, which is obviously communications being a key challenge. Whereas for IM-2, our second mission later this year, we'll go even closer to the pole.
It should be.
So for example, one of the things that we can study is, while we see the Earth all the time, it's still close to the horizon. And one of the things that communication engineers want to know is how communication is affected when the Earth is really close. So that's one example of something we can do in support of Artemis.
Well, thank you so much for joining us here today, Ben. That's all the time we have right now. We're going to send it back to Josh and Gary to talk a little bit about the landing sequence.
Thanks, Leah. Yeah, Malapert A is a fascinating satellite crater to Malapert, a crater only 300 kilometers from the moon's south pole. The site is...
Guys, light speed, or C, is 333,000 meters a second, Moon's 200 and how much is the moon? How many kilometers away is the moon? I know it's 250,000 miles. My brain's too potato to do that, to put that in kilometers right now. So the delay is about a second. Not bad. Not bad. The moon is not that far away, especially not on a light speed scale. Think about it. There's John Young. That's Apollo 16.
That may help better characterize this.
It's not a big deal. The computers are landing it anyway.
And Gary, we were originally targeting from NASA Oceanus Procellarum. It was a lunar mare in the region of the near side of the moon. The decision to move from the original landing site in Oceanus Procellarum was based on the need to learn more about terrain communications near the lunar South Pole, which is expected to be made up of some of the best locations for sustained human presence on the moon. Landing near Malapert A also will help mission planners understand how to communicate and send data back to Earth from a location that is low on the lunar horizon.
Now we're coming up on the NDL activation. We have more information about how Intuitive Machines flight controllers intend to land on the moon using this NDL, NASA's Navigation Doppler LiDAR.
And Gary, since choosing to orbit the moon one more time, flight controllers have been working to resolve a challenge with the lander's laser rangefinders assigned to the terrain relative navigation and hazard relative navigation cameras. Those provide landing solutions to Odysseus. The lasers are intended to determine altitude and horizontal velocity, but the ones on the lander right now are not working.
These are essential measurements required to land on the moon. And while Novasea's laser rangefinders are not operable, NASA's Navigation Doppler LiDAR sensors are.
So during the last 2-hour orbit, flight controllers have been loading software patches and resetting the lander's guidance, navigation, and control system to use 2 laser beams from NASA's Navigation Doppler LiDAR as primary navigation sensors to land Odysseus.
That's right, and we're coming up on the timeline for when Nova-C is about to begin the activation of NDL. This is a 3-step process from powering on, becoming ready for operation about 5 minutes later, and then integrating those sensors with Nova-C's terrain and hazard relative navigation cameras ahead of Nova-C landing. So while we wait, let's learn a little more about NDL.
So the Artemis program has taken NASA back to the moon, and everything that goes there, including the instruments and people, must be flown there safely and landed there precisely. So the landing phase of that task is one of the most critical aspects of it. NDL is a LiDAR instrument that is used to enable that capability. It uses light in the same way that sonar uses sound. For NDL, we have 3 telescopes where light would come out of the telescope, hit the moon's surface, and some of that light will be reflected back. These telescopes are mounted on the outside of a vehicle so you get a clear view of the ground as it's coming in for a landing. In the Apollo era, large radars or astronauts using their eyes looking out of a viewport were used to help land the vehicles. NDL is going to have to take the burden off of the crew with a much smaller, lower power, and more accurate instrument.
Rock on.
And we just got an update from one of the flight controllers that the HRN and TRN cameras assigned to Nova-C are still nominally processing images using 2 of those NDL lasers. Quite the feat, Gary.
No, it's absolutely incredible and a very important milestone to reach. Now, with that understanding, let's learn more about how this technology is playing an active role in this dynamic situation. Let's head over to Leah Cheshire. Leah?
Thanks so much, Gary. I'm joined now by Prasanth Desai. He's NASA's Deputy Associate Administrator for the Space Technology Mission Directorate. Thank you so much for being here.
Grateful to be here.
So let's talk a little bit about the novel landing technology that is NDL. Can you explain that to us?
Yeah, so NDL stands for Navigation Doppler LiDAR. And one of the challenges for doing any space missions is knowing where you are and trying to figure it out, right? And so we're looking to develop newer capabilities that we can do that more precisely and that take up less volume and mass on the spacecraft so that you can have all the available payload mass for instruments and other scientific things we're trying to do. And so this is the next generation of a new capability where we're trying to go from the traditional measurement using radar to a laser-based system. And so that's what this navigation Doppler LiDAR will be doing, is sending out 3 laser beams to try to get the velocity measurements in the lateral direction as well as the vertical direction.
So when it comes to NDL, what are some of the challenges we expect to see when using this technology?
So we've tested it on the ground in a number of platforms, from helicopters to landers here on the surface, on the Earth, to test this out. But this is the first time we're going to test it actually in the space environment on a lunar surface, right? And so we will see how that different environment will really affect the systems, right? And so one of the things that we would really like to know is what how the pulse comes back after they send the laser, and how it reflects back to the system, how long it takes to process, and how it will help define the solution to figure out the trajectory to go down to landing on the surface.
Now, this technology has become a little more critical for today's mission, so can you talk about how NDL is now being used in today's landing?
Right, so we put this as a tech demo with tech demonstration as a test, right? We weren't planning to use it in line with the actual mission coming down to the landing, but now we are. So basically it is now the primary system to help provide the velocity and altitude information so that the lander can land safely on the surface. And that's important because as the lander comes close down, we don't want it to tip over. And so we need to get an understanding of the vertical velocity so it knows how much thrust to slow down, but also the lateral velocity, because if it comes down sideways too much, it can tip over and fall. So by knowing the velocity, the lander can decide exactly how to come down and hover, basically slowly to come down, and that's why it's really important to do this testing. But here we are today. We're going to try it for the first time in line, and so we're very excited for the mission.
Yeah, a demonstration totally in action.
Yes.
So just very briefly, there are 2 other tech demos on this mission. Can you cover those very quickly?
Yeah, so 2 other things that we're trying to improve on is one, radio frequency mass gauge, which is to try to get a measurement of the fuel that's on any system, any spacecraft. One of the things about low gravity is the propellant doesn't settle down, where like in a car gas tank, it's on the bottom so you can measure it easy. In space, it floats. And so how can we do that so we know how much propellant there really is? And then the other one is scalps. One of the things that as it lands, the thrust is going to throw up all this eject of the lunar regolith and thing. And so we have 4 stereo cameras that are going to take images of that and get data so that we can improve our modeling, so that in future landings we can make them more safer and things like that. So we're using that as a technology demonstration as well to improve future landings to make them more safer.
Well, thank you so much, Prasanth. It's really been great speaking with you, really exciting stuff. And for now, we're going to send it back to Gary and Josh.
Gary?
Hey, thanks, Leah. Nova C is a little less than 55 kilometers from the lunar surface and about 20 minutes to powered descent initiation, a critical maneuver that marks the beginning of Nova C's final moments before touching down on the lunar surface. It's no secret that landing on the moon is challenging. Countries around the world have attempted this incredible feat, some successful and some not. Of course, the United States has landed on the moon many times, most notably during the Apollo program. But this may be the first landing by a U.S. commercial company, enabled under NASA's CLIPS initiative. Ahead of these important milestones, let's discuss the challenges of landing on the moon through CLIPS. Take a look.
38 miles, GG.
Landing on the moon is hard. We're going back. Under this Artemis program, we're going to be sending humans to the moon for the first time since Apollo. So ahead of humans, we want to get up as much science exploration and technology experiments as possible.
So CLIPS starts facilitating a lot of the early science, the things we want to learn before we even send humans. CLIPS stands for Commercial Lunar Payload Services, CLPS.
The services part is the key element. Ordinarily, when NASA delivers a payload to the surface of the moon, they do it with a commercial partner, but NASA controls the building of the vehicle. Now, we're buying the service of delivery of our lunar payloads to the surface of the moon.
It is a delivery service, akin to a delivery service that you have here on Earth.
NASA will provide payloads to a commercial company. They decide how to get it to the moon. They have to develop their own lander, but they also have to manage the entire end-to-end mission.
It's meant to provide affordable, rapid, frequent access to the lunar surface through American
I miss Dan
companies.
as well, Danzu.
We're funding different companies.
Gary and Lee are cool, though.
Commercial
They're all right.
companies that are competing to win task orders to deliver our payloads to the surface of the moon.
One of the goals
It's just
when
a
we
lander,
started
Stormy.
CLIPS was to
One-way
help
trip.
establish a lunar economy.
Somebody has to do it first, and then it becomes commercially available. Then they're able to crank them up. Then they're able to make it more affordable. And so the lunar surface is just the next frontier.
No one's on board, Spencer.
But we had to acknowledge up
this is the
all
probe.
through the highest levels of the agency leadership
this is the
that some of them will fail.
Like,
these missions may not be as successful as a traditional NASA mission.
It's a landing test, basically.
Accepted the risk that going through this innovative approach with these commercial companies, that there could be some failures. Some of them are new companies. None of them have ever successfully landed on the surface of the moon. So they're going to learn lessons.
We need to give our vendors the opportunity to learn.
And so that'll help ultimately buy down our risk as these companies learn, okay, what does it take to actually build up the lunar lander, integrate payloads, get to the lunar surface and land safely?
They've been able to demonstrate that they have very, very good technical
pretty much, dogs,
and the ability to design and execute missions. We're willing to take more shots on goal. And we aren't risking human lives. And in the big picture, if we're flying missions at 1/10 of the cost of a NASA mission, and we fail 2 of them, we still get 8 missions for that same price.
Even with 1 or 2 or 3 failures, this is still a very economical proposition. It's a risk posture which is more risk tolerant than NASA is accustomed to. There's not a single one of these companies that's willing to bet their mission on a coin toss. Every one of them is doing what they can in order to have the most successful mission
half-hour
possible.
logo.
But the important thing to realize is that risk tolerant does not mean risky. And the rewards are a long-term ability to get payloads to the moon inexpensively, frequently, and rapidly.
We want science, so we can then put more of our resources on even more science, exploration, and technology payloads and get more of a return on investment when we get to the moon.
Guys, I'm going to run an ad at T-minus 15 minutes. That should give us about 15 minutes to get through all the landing, and 15 minutes after that, uninterrupted, no ads. It would kill me if a pre-roll ad popped through right when the thing goes to land. So I'm going to run some ads just in case. Because I hate them. And especially when they're interrupting whatever you're watching. It's really, really annoying.
Gyre, who's standing by with NASA's Associate Administrator, Leah.
I'm just trying to stay awake.
Thank you, Gary. I'm joined now by Jim Free, NASA's Associate Administrator. Thank you for joining us, Jim.
Thanks for having me.
This is a big day, and what are some of the challenges to landing on the moon that people might not expect?
Well, it is a big day, by the way. You're right. I think the challenges are multifaceted. First, getting into lunar orbit is a challenge. Going to the South Pole is different than going to other parts of the lunar surface. The lighting conditions are a lot different than at the equator. So you have your hazard detection has to be a little more reliable. You have to be able to do that last minute avoiding of the hazards that are on the surface and finding that right place to set down so you're also level or within a tolerance that you can be for level on the surface.
Dogs, what are you saying? You've probably said it. What is the purpose of this? This is a precursor mission. Part of it is to analyze how certain vehicles land on the moon, analyze the area around potential landing zones for a base, dogs, down on the South Pole. And it's basically it's testing landing, it's testing Intuitive Machines' ability to be able to land. There's a bunch of different things, and then there's a bunch of science missions on it as well. Any science missions from tracking how the dust gets kicked up from the engine, all the way to navigation systems, there's like one payload on this is called the Eagle Cam. The Eagle Cam is a camera that's in a dispenser on the side of the thing that's actually facing inward. Right? The camera is facing towards the lander. And what the thing's going to do in the last 30 seconds, it's going to eject this probe with a camera facing towards the lander. And that camera, if it works, will provide us the first ever footage of something landing on the moon. We've never seen that from another perspective other than on the vehicle. We have seen some ascents off of the moon, most notably Apollo 17, from the third-person view, right? But, yeah, it's not just a landing, dude. You know, if we're going to go back to the moon, we better start analyzing what are the effects of landing and taking off from the moon all the time? That's what Nova C, oh, come on, Glenn. 10 subs, thank you. That's what Nova C is basically doing. It's a pathfinding mission, not only for intuitive machines, but for NASA as well, under the Commercial Lunar Payload Services Program, which is a part of the Artemis program. That's a subset of the Artemis program. Just like Surveyor was a subset of the Apollo program. Surveyor were the first probes that the U.S. first landers that went to the moon. And what was their purpose? What was the purpose of the Surveyor missions? The purpose was, well, to make sure that you can soft land on the moon. You don't want to send somebody out to the moon without knowing that information. That would probably not be good.
Discovery, go at throttle up.
30 seconds or 30 meters? Nope. I don't understand. Nope. Hey, Older Buffalo with the 5-pack. Monblend, thank you for the 10. Older Buffalo, thank you for the 5. I do appreciate it, guys. Appreciate it a lot. Thank you. I hope you guys enjoy this. This is live. We're 25 minutes out from the landing. We should be about 5 minutes out from powered descent. PDI for short.
To ensure a safe landing. We've highlighted 5 of the 6 NASA payloads
so far
throughout our broadcast today. Let's talk about the final NASA payload, LN-1. Lunar Node 1, or LN-1, is a small CubeSat-sized flight hardware experiment that integrates navigation and communication functionality for autonomous navigation to support future lunar surface and orbital operations.
Here, listen to this one, dogs.
Lunar Node 1 is meant to be a demonstration of how we can use various navigation technologies to figure out where you are in and around the moon.
Someone gifted Erudite sub and Hypersonic had 5. Thank you, guys.
The Lunar Node 1 mass simulator. We use this build to test out our vibrational modes, put on a shake table, and also do fit checks with the lander itself. Inside of our payload, we have multiple electronics boards that fit within this chassis that is a little bit about a half a U in size. You can see our external connectors here where we have our data and power to the lander itself. And within here, we have multiple boards that do the power regulation, our data control, our FPGAs, all those kind of electronics pieces are in here, as well as a small S-band radio that attaches up underneath this top radiator in order to distribute this heat, and then the top to the antenna, which mounts here. This is the same size and build as the flight payload. It's just not covered in MLI or some of the other materials that you'll see on the flight build itself.
Navy lady, who knows? So, what's the intended speed of the lander during descent? Well, the intended speed at the end of it is going to hopefully 0. But it's going to descend slowly over time. The idea is to make it so, say the thing is going like 5,000 miles an hour. They're going to burn the engine in such a way that hopefully by the time you get near the ground, your altitude and your velocity both hit 0 at the same time. That's part of the reason why it has all these relative navigation systems on it. So it makes sure when the engine shuts off and it gets to 0, that it's able to maneuver and land in a spot where it's flat enough to do that. No, it's going to go one way or the other. Actually, we don't know that until PDI is completed. PDI is the point of commit, powered descent initiation. That's when you start your what's called a retro burn to land down on the surface. When we get past that point, it's going to hit the ground. Let's just hope it does it in one piece. We're almost coming up to that point here. Hey, Monblend, tier 3, 27 months, dude. Thank you for all the support. I appreciate it. I love covering this stuff with you guys. I appreciate your support. Like, I can't say that enough. It's truly a pleasure. Truly a pleasure. Some of the range finding equipment is not working with, but they have a secondary. They have a 2-fault redundant range finding system. There's a NASA rangefinder on it, and there's an Intuitive Machines one on it. If one goes, they can use the other. Holmes, thanks for the Prime sub, dude.
After landing, Intuitive Machines also had several cameras on the lander, including wide and narrow field of view cameras. They started the mission with incredible imagery as the SpaceX second stage deployed our Nova C lunar lander, capturing iconic images of the Earth after separation. It requires a lot of planning, work, and just a hint of luck. Payload Integration Managers programmed the lander's wide and narrow field view cameras to take 5 quick images every 5 minutes for 2 hours, starting 100 seconds after separating from SpaceX's second stage. Out of all of those images that were taken, we ended up with just 4 inspiring ones to show humanity's place in the universe. And right now, we're a little more than 10 minutes from powered descent initiation. Let's go to Leah Cheshire one last time for the final interview ahead of this critical maneuver. Leah.
Thanks, Josh. I'm here now with Nikki Fox, NASA's Associate Administrator for the Science Mission Directorate. Thanks so much for joining us.
Thanks for having me. This is a great day.
It is a great day, and you're watching this with leaders from NASA and Intuitive Machines, just very close to hear.
Hey, Nico.
What's happening in the room right now, just before these final?
Good day for that.
Oh, there's just excitement, anticipation.
Well, let's hope.
You know, everybody knows landing on the moon, going to the moon is hard. And we're already celebrating because this mission is already a success. You know, this is we've launched, we had a beautiful launch. We've taken great science data all the way, every single challenge. The team has really risen up and solved it. And now we're in lunar orbit, you know, minutes away from starting our descent down to the lunar surface. So for me, so many successes with this mission already, so just a lot of excitement.
I'm loving that. So we are working with these American companies in a very unique way. These are challenging goals, and some people would probably consider this a bold endeavor, but what does it mean to you when you look at pursuing challenges in a bold new way?
I mean, you're right. It is bold. It is a new way of doing science. It is a partnership with totally new companies who haven't done these things before, and we are partnering with them, and they are taking our science. It's a way for us to get more science and more technology to the moon quickly. So it's faster. It's very cost effective. It's very efficient. We're on our way. We've got the 6 payloads from NASA, and we're excited to get them down there. With every new thing we do, there's always a challenge, there's always risks. This is a high risk but super high reward, and it'll get tons of science on the surface. And for my NASA science, this is exciting because our Artemis missions and our lunar science touches all 5 of our science divisions in very profound ways. So super excited.
You said high reward, so I want to talk for a minute about the valuable scientific insight that we can get from the moon. What is that? What does it mean for NASA?
I mean, there's so much we can do on the moon, particularly where this one is going down to the South Pole. We think we're going to find great volatiles down there. So as we get prepared to send our astronauts there, then we know that there's water there, and we can use that water. Water's very heavy to carry, so it's really great if you can use it on the moon. We can break it up into hydrogen and oxygen, use it for fuel. Really great for our sustainability, but also where they're going is one of the oldest regions of the moon, about 3.85 billion years old. So we can actually learn about what our solar system was like before life started. Life is very noisy. We're very, very noisy here on Earth. The moon is just like pristine, and so we can really do some amazing science.
I look forward to learning more about it. So any final words before we wrap it up?
About 15 feet tall.
Thank you. I mean, literally, thank you.
Pounds.
This is such an amazing team. You know, thank you to the people that put the science and the technology experiments on with us, those teams. Yeah. Thank you to the commercial teams that put their instruments on and are riding with us. Thank you, of course, to Intuitive Machines for this just beautiful, beautiful lander. And thank you to SpaceX for a beautiful ride to space. It's such an incredible effort, all one. I don't know, I'm a big bundle of emotion. Go NASA, go CLIPS, go OD, go Intuitive Machines.
I'm with you all the way. Thank you so much for joining us here today. Now we are following Intuitive Machines flight controllers during Nova C's final descent. So back to Josh and Gary.
Thanks a lot for that, Leah. During that interview for folks at home, we did hear that there was a maneuver to burn attitude, which means the lander is starting to make the positional requirements needed. And we're going to start listening into the IM-1 channel so folks at home can hear.
Guys, I'm gonna run the ads now so we can get uninterrupted all the way down to the surface. I'm gonna do it. So I'll see you on the other side. Once again, I don't like running ads. I hate it. But what I hate even more is having a broadcast interrupted by an intrusive ad. If we do them where it makes sense, then we can all watch this with no interruptions.
further operations. And while we were in that interview, we did hear that the main engine gimbal checkout was completed. So now we're focused on the operations with Nova Control. For folks at home, we are listening in to the live channel there.
That's right. A lot's happening in Nova Control. We're going to be hearing these status calls periodically as we follow the flight control teams
There's enough up
that
there,
are
cats, to keep a
monitoring
moon
Nova
base
C's
going
descent
for a
towards
really
the
long
lunar
time.
surface. A lot's happening, Josh. Of course, we have this 11-minute burn. We're focused on the propulsion elements of
That's
this
cool,
PDI.
henchman.
At the same time, the spacecraft
cool.
is
Thanks for telling me
oriented in
that.
such a way that it can use a technology called terrain relative navigation to scan the environment along the way. What's happening there?
Right, so we know that we needed terrain relative navigation then when we were descending and coming down to the lunar surface. Now, this involves two pieces. You have a camera and you also have a laser rangefinder. At the top of the show, we started talking about, hey, the laser rangefinder that Intuitive Machines put on Nova C, it's not operating. We made the decision for flight controllers to utilize 2 of the laser beams from NASA's NDL payload, make the software patches required to reassign those lasers into the TRN and HRN cameras in order to give us an opportunity to land on the south pole of the moon today. Gary, is quite the feat and challenge overcome in just about 2 hours because we elected to delay that orbit and go into another orbit. That's why the show was a little bit later. It appears to be paying out. The last call-outs that we heard, Gary, were talking about beginning processing optical images, and that was nominal. The last time we heard that was just about 20 minutes ago.
The status checkouts of these critical systems are essential to understanding the performance. The folks you see now on your view, this is Nova Control. They're monitoring every step and all the data coming from Nova C ahead of PDI, which is scheduled just a little bit after 5:11 p.m. Central Time. Exactly what are these folks looking at, Josh?
Well, right now everyone's looking at their assigned screens, and all of them are tailor-made. Generally, there's a few who are looking at the same type of screen, but they're tailor-made for their task. You have Spark looking at electronics, things like how hot are the electronics. Payloads are monitoring different parts and pieces. In
5 degrees to burn attitude.
5 degrees left until burn attitude. The vehicle's still getting ready for this PDI ignition, which we expect here in just about 2 minutes, Gary, two minutes. So everyone's looking at their screens and doing their respective jobs and reporting up into the mission director, while the activity director is keeping in touch with everybody and making sure we're putting this whole thing together.
Press started.
There's a call for tank press started. Just a little bit before that, Gary, we did hear that they were working on the cryo fill. So these are all steps that are leading towards PDI, powered descent initiation. We expect that to take about 11 minutes, where we're slowing Nova C's velocity approximately 1,800 meters per second, and that's required to get this lunar landing opportunity in just a few minutes.
90 seconds to TIG. Propellant tanks at flight pressure.
All right, 90 seconds until we begin that propulsive maneuver. Again, power descent initiation is about a 10 or 11-minute burn that will slow the spacecraft's descent. A lot's going to happen after that 10 minutes, Josh. This is a single
the start of the
continuous
descent,
burn.
guys.
After that, we're going to see a lot of events in rapid succession: pitch over, vertical, and terminal descent.
And we just heard another call out from the prop console saying that feed line prep is complete. What that means is Nova C's propulsion system, that mixture of liquid methane and liquid oxygen, that feed line is prepped, getting ready to go into an injector to blend those two propellants, the propellant and the oxidizer, and have ignition of PDI.
Man.
We're tracking that in just under a minute, Gary.
I want to move over here.
Converging on burn attitude.
Okay.
Lander is getting into the correct attitude required.
Feed line prep complete, both sides.
Another call for feed line prep complete for liquid methane and liquid oxygen in preparation for this PDI burn.
Stand by for the call for powered descent initiation. Once again, PDI is the start of the lander slowing down.
15 seconds, exec mode.
It's the lander slowing down.
15 seconds to exec mode. We're tracking a little less than a minute, though, until the time of ignition for powered descent initiation.
Settling.
Prop settling is complete.
Ignition.
Rate settling.
Throttling up.
Is complete.
Main stage.
Okay.
There we heard main stage ignition. That's coming from our prop console, Rob
Good
Moorhead.
control.
Good control
GNC call on good control.
Thrust to weight 1.5.
FIDO reports full thrust.
These are great call outs in between our prop console and our flight manager, Scott Tamblin. calling it as the data is feeding into the lander, which means we are continuing to have good communications. The lander is sending that back to flight controllers in Nova Control. Gary, something we prepared for, we planned on, is that loss of communications, and that's why we have this.
I see good thrust control.
It's a good thrust control call from Prop, but that's why we have this autonomous lunar lander. You know, we programmed, we know that, hey, we want to light PDI in this moment. These are the steps you need to get there. But from here in, this is an autonomous lunar lander, and flight controllers are monitoring communications and tracking the progress right along with the public right now with us.
Nova C has the helm. It is in control and is making the decisions necessary to ensure a soft landing. We heard call-outs about thrust, full thrust right now. There is the ability to throttle that thrust, and we'll see that throughout the descent as the fuel tanks continue to unload and we expel that propellant.
And we did have a few questions come in about how much gas are we giving this to slow down the vehicle. And we want to remind folks that this PDI burn goes
commanded thrust 90%.
Goes in just about 90%, right on time. So it goes in at 90% in order.
The computer just commanded the engine to throttle down to 90% to it, basically to adjust for any potential wonkiness in the descent trajectory. Basically, the computer's updating where it is in the guidance systems, and it's making the adjustments to the motor to do a precise landing.
All right, but my display's a little bit stale.
That's a mission director, Tim Crane, calling about 500 kilometers, but stating that his information might be just a bit stale.
1,000 PSI in the helium tank.
Good PSI.
That's part of the reason we're showing this animation, Josh. Of course, this is not telemetry driven. We're just showing you exactly what's happening. As we hear the calls, this information is relayed through the audio loops. Not enough bandwidth to do a live stream of this, so we're relying on the data that's being fed from Nova C to Nova Control.
Yeah, that data is going into the flight controllers, and what you're seeing on your screen right now is just to give you an idea of the vehicle's attitude. You heard them talking about moving to a burn attitude. This is what we expect Nova C is doing right now. It is a simulation in the large screen just to give you an idea of what's happening over these critical approximate 10, 11 minutes of PDI-powered descent initiation, trying to slow Nova C down, bring that acceleration down to about 1,800 meters per second. And there's some follow-on steps after that, Gary. It involves pitching over the lander using that gimbaled engine. We heard the maneuver to burn attitude followed by main engine gimbal checkout. So they'll use that gimbal to pitch the lander over and start a vertical descent. This is where we start getting a little tricky as far as there is a final approach. It may add a few seconds, it may add a little bit of time, but we are intended to land right around 17:24. That's 5:24 p.m. Central Time, but know that there is some give and take. We're also expecting, planned for, and trained for a little bit of loss of communication during this process.
That's right. And that communication is absolutely important. And part of the reason, and we've been stressing this, Josh, is the autonomous operations of Nova C. Part of that is after it performs that pitch over maneuver.
400 seconds to go and braking 1. Good control.
Good call.
Fido, I see TRN depause processing.
From the Fido?
In flight.
All right, that was the call that we were waiting for. That was our major problem we've been working on in this dynamic situation, is getting those images processed from HRN camera, TRN camera, which in this case, a dynamic situation, we had to improvise a little bit, reach into those 2 laser beams from NDL, figure out a patch while we were in lunar orbit, just about 2 hours, and it sounds like we are getting good readings from those images. Absolutely remarkable feat. We also happened here, I think, was 400 seconds remaining. That was coming from Fido and Flight Dynamics. Sean Stewart working the console this evening.
Yeah, actually, no, not less than a second, a little bit more.
Calls to hear. Hazard relative navigation is going to be used after the pitch over maneuver. This allows Nova C to make some decisions and scan the landing site underneath it and make decisions in an area that calculates
8 minutes, guys.
The terrain to make sure that it's landing in a safe landing zone.
Right, so we finish up PDI, pitch over, and we have to use that hazard relative navigation, a critical tool in order to land on the moon, to make those decisions, right? There's no human eyes, human elements deciding, okay, I see the hazard, I need to steer this way, or maybe press the gas, press the brakes. This all happens autonomously, and this is a huge requirement and a great call out to hear about the HRN camera system and processing those images. Right now, I am tracking 5:16 p.m. We expect PDI to go until about 5:21, 5:22.
It's a long burn.
300 seconds in breaking one.
Or about 300 seconds to approximate those numbers.
Very precise.
Seven minutes.
Josh, after those final series.
Thrust to weight is 1.7.
TWR is going up 1.7.
Following along after those critical maneuvers.
Commanded thrust still 90%.
Commanded thrust
90% thrust. We'll hear those call-outs periodically. We started at full thrust, 90%. Still throttling. And good performance on that engine.
That's a great call out. Two things there. Nominal performance on this engine as well as the helium tank. So what we haven't mentioned so far in the show is that the helium tank pressurizes that liquid methane and liquid oxygen tank. But in addition, it's also used for reaction control system. Those are the small spurts that you see at the top of the lander in the animation that control the vehicle's attitude. So for things like landing on the moon, you really want to land at the right attitude. That way your antennas are facing back, direct line of sight to Earth, and you can get that ultimate confirmation once you do suspect that you have landed on the moon.
The antenna alignment is an important element of landing on the moon, Josh. We're expecting the high-gain antennas to be pointed towards Earth to confirm, but there may be a delay.
We are expecting some sort of delay. I had just talking to the mission directors about how quickly we could receive a positive confirmation after this landing process is through, and there was some dispute over how long. The earliest was just about 15 seconds after we see timing of when the event is supposed to happen. So right now we're tracking about 5:24 p.m. Central Standard Time. So maybe anywhere from 15 seconds after that, maybe a few minutes, 2 to 3 minutes while we work to acquire that signal. Because as you mentioned, the lander is going to a general area.
9 kilometers altitude.
9 kilometers altitude call from Tim Crane.
Pretty much, gotcha.
The lander is going into a general area that we say, this is the general area we want you to fly to. It's using that hazard relative navigation to make better decisions about this is an area with the least amount of slope. This is an area that's free of boulders and other obstacles. So it's making autonomous decisions about where to go.
3 minutes to go, breaking one.
3 minutes call.
180
Just to wrap that up, when
PDI.
the lander is making those decisions, Gary, it's also very difficult to track. We've been very fortunate thus far tracking communications to this point.
To wrap that up, Josh, 3 minutes, that brings us to just shy of 5:22 p.m. Central Time. We should hear that the power descent and initiation burn is complete. Then we'll begin the next series of maneuvers to get us towards vertical and terminal descent. It starts with the pitch over.
And just looking at our notes here, we did go into this burn expecting pitch over at 5:21 and 57 seconds. So good call out on the timing of that maneuver. It's important to remember PDI starts an engine burn that does not stop until landing. So this is a throttleable liquid methane, liquid oxygen engine. We lit the engine at PDI, and while we are changing into a pitch over, vertical descent, and terminal descent and then landing, that is a throttle down to the lunar surface. And when we do get out of PDI, if we hear that call of PDI complete, good burn, everything after that is going to happen in very quick succession, Gary. The time it takes to go from pitch over to landing, or what we estimate landing to be, just looking at maybe 90 seconds is what we expect nominally.
3 minutes to touchdown.
There is some wiggle room. 3 minutes to touchdown call from the mission director.
A little bit ahead of schedule. If you guys notice that T minus 3 minutes is not syncing up with the clock up there, that is those relative navigation systems that they're talking about, adjusting the ascent. So the timeline might be a little different. They might land a little bit faster. They might land a little bit slower. In this particular case, it seems like it's going to fly a little bit more downrange because of the desync time. So, yeah, if you see up here, he calls out 2 minute 45, right, and it doesn't say that up here, that's because the onboard computers, that relative navigation system, is changing the trajectory.
Originally planned for from those 2 laser beams from NDL, it appears and sounds like that solution is working, and the people working to patch that software were certainly under pressure. The clock was ticking as we went into that extra lunar orbit. It wasn't a situation where we could just sit in lunar orbit and try to solve our problems indefinitely. And it sounded good so far on the call-outs.
2 minutes remaining till touchdown.
See?
2
15
minutes
seconds
to
ahead on
touchdown.
the
That
schedule.
required a patch to be designed on the ground and uplinked to Nova C to confirm that those laser sensors on NASA's navigation Doppler lidar could be routed to the terrain relative navigation and hazard relative navigation. That call out is fantastic.
Fighter, do you have an altitude reading?
Mission director just pinged Fido for an altitude reading.
Standing by to see if we can get an altitude reading from Fido here.
That's this guy.
That's Flight Dynamics Officer Sean Stewart on Blue Team.
Come on. Come on, give him an answer.
Confirm that looked like a pitch over gimbal. Let's do it.
Sounds like we have some data that confirms pitch over. This starts the HDA process. That's hazard detection avoidance. Throughout this show, you've heard Gary and I talking about the problem that was attempted to be solved in lunar orbit, making the decision to not only postpone this show.
NDL indicates altitude of 1,000 meters.
2/3 of a mile off the
1,000 meters
deck.
call out from NDL. That is coming from flight management. This is a system right now. NDL was not intended to be the primary landing system on this. Instead, we're using 2 laser beams from NDL and feeding that into that hazard detection and avoidance system that you see on your screen right now, with the lander making autonomous decisions about where it wants to land. That is generally
less than 1 minute remaining.
Here we go.
To touchdown.
Less than 1 minute remaining for touchdown.
And again, that's the time of touchdown. It may take some time to actually confirm the status of the lander.
And in this process, we do have a deployment of Eagle Cam attempting to take the third-person images of Nova C going down to the lunar surface. We are inside of 1 minute, Gary.
Yes, we're well on the blowdown.
And we're tracking here in the broadcast booth. The clock has reached the expected.
May take a minute for comms to reestablish standby.
There it is, mission director beating us to it. We've reached the expected time of landing, but now is the process of waiting for comms, and we are in standby mode, as you heard it from the mission director, Dr. Tim Crane. And 1 minute has elapsed from the notes that we have, Gary, of that original burn starting at PDI.
And you have carrier lock.
That's MD asking if we are getting the ground stations locked on to Nova C. That carrier lock call, Gary, we expect that to come from GroundNet or COM. That conversation possibly not happening on our public channel that we have access to. We're just standing by to hear that come through the channels as we approach almost 2 minutes since we estimated the landing time. We did get a few call outs on the side, folks coming into the room saying there was about a 2-minute forgiveness in our timetables.
We are checking our antenna reception.
Checking antenna reception.
Give them a second, guys. It's going to take a second to reestablish communications. Right when the rocket gets near the ground, it's going to start disrupting the signal. A little bit. That always happens. Because kicking up dust and whatever. So we'll wait for confirmation of signal lock here.
And we're standing by, Gary. We're standing by just as we approach 5:26 p.m. Central Standard Time. Given those mission directors' notes of the flexibility between what we were tracking, what we were given was just about 5:24.
All stations, this is MD. Please look back through your logs and confirm the last information you had, and we'll determine this is a comm outage.
And that's the mission director, Gary. These are our notes here of what we believed. We talked about the comm outages with the lander making autonomous decisions. This is the process of going through the last bit of data that came into Nova Control and working to verify, okay, this is the last bit of data. Where was the lander possibly going? How do we look for it and establish those communications? Nova C uses 4 antennas placed at the top of the lander that are designed to capture these communications. But we did expect this. We talked about it, that this is a communications challenge in it of itself, and right now we're standing by to hear that communications call out.
We're just a little more than 3 minutes from the time of when the clock reads 0 for Nova C landing on the moon.
It's going to take a while for that dust to settle because 1/6 the gravity, right? So it's going to kick all that stuff up, and that dust is going to come down in slow motion. So it might take a second. That wasn't me, right?
Discovery, go and throttle.
They muted comms. We'll see.
And we just checked with our team here in the broadcast booth, decided to let's stay on this. All the chatter we are not hearing on this public channel, Gary, all things indicate that we are working to solve a possible communications challenge in this moment. So we're going to continue to stand by.
For those following along.
MD Prime on IM-1.
Hold up.
Go for Prime. Yeah, I guess you polled the room looking for states, and we're going to go ahead and cycle the ground transmitter on Goonhilly and do some RF sweeps. Is that your plan? That's correct. Roger, copy.
They are going to
And that's just what we had in mind in our notes, Gary.
They're going to shut the ground station off. The tracking station, they're going to shut it off and turn it back on again. I'm not kidding. They're power cycling the ground station.
What you just heard there is folks talking about using the Goonhilly Earth Station Limited dish in the UK to do a sweep looking for that signal. We mentioned that autonomous process of the lander reassigning itself somewhere that it believes is safe. Going into it, we heard that the HRN camera was functioning and able to make those decisions after what was a 2-hour orbit of problem solving with Intuitive Machines' TRN and HRN cameras, the laser rangefinders assigned to those. Those are the ones that Intuitive Machines installed inside the navigation pods. The laser rangefinders were not activated. We went to NASA and asked to use 2 of the laser beams on the navigation Doppler LiDAR.
That's right.
And spent 2 hours in orbit.
Team, we're going to confirm our pointing vector with our antenna for post-landing.
Okay, so they're not.
We spent about 2 hours in orbit
contact
to solve that problem. We got good readings on the way down. And right now, we are working to confirm communications on the surface of the moon, roughly around the Malapert A region. That is the South Pole region of the moon.
That's right. What we do know is the power descent initiation. We were following along on the status calls. We executed a pitch-over maneuver, and we're counting down the clock to a landing time of 5:23 p.m. Central Time.
This doesn't
Josh
mean
described those
something is wrong.
processes
This means
working on the communications component to confirm data from the lander, pulsing the teams surrounding him to check the status.
You really want to look for
Nova
this.
C and the data that they were receiving.
People in Mission
here,
Control are
Nova
doing
Control.
this. If they're doing the not like this
Part
face,
of that,
that's
Josh,
when
as you
something's
described,
wrong.
Is communications. We're standing by.
Fido MD on IM-1. QMD. I'm looking at our phase plane there for the last part of the flight. Looks like we had excellent pitch and yaw control throughout, but I did see a little bit of a roll excursion. Could it be that we landed off angle and roll in the final phase?
Oh.
So I do see we had up to an 8-degree excursion. We're about to begin the roll maneuver, which is about
terminal phase.
The terminal phase, which is a large roll maneuver to get to landing attitude. That's the last data point I have. But up until that point, we were really solid.
Right, so terminal phase begins at 30 meters?
It may
Or
have tipped
post
over,
HDA.
but
Post HDA,
we don't know for
400
sure.
meters.
Very good.
So what he just said, he was talking to the flight dynamics
And that's
officer.
a great conversation.
He's talking to the flight dynamics officer. This is the guy that's watching how the vehicle is flying. Flight dynamics. He said the mission director asked the flight dynamics officer if what the rates were. Did it look good? So what do the rates mean? They're basically indicators to say what axis, pitch, yaw, and roll, with 3 dimensions, 3 axis of rotation, right? What dimensions the vehicle was, what the rates were during the descent. And he said there was a little bit of a component, or a little bit of a roll component, up to 8 degrees. I would assume that he's referring to 8 degrees a second radian, which basically means it was slightly rolling, just a little bit. But, yeah, he said that happened during the terminal phase, so we'll see.
The largest, most powerful dish out of all of them is about a 64-meter dish in Australia. That time to search with that opportunity with the largest, most powerful dish, we're looking at about 12 to 13 hours after our estimated touchdown. So this is a process that we could be looking and searching for the lander's signal for confirmation for quite some time, but we're going to continue to listen in and stand by as our flight controllers are working with the ground station in the United Kingdom to work this issue. Work this problem. It's another challenge, very similarly to the challenge solved just to make it this far.
Science of life, we have a return signal we're tracking.
Electrical confirms return signal on the lander, but weak. I actually don't think that would be electrical. I'm not sure what station that is. Yep. Okay. Remember, there are 4 antennas, so you have quadruple redundancy there. If it's a weak signal...
We have an onboard fault detection system for our communications that after 15 minutes with lack of communication will power cycle the radios, and then after that, for another 15 minutes, it will then switch antenna pairs. So we have some time here to evaluate. We do have signal that we're tracking, so we'll see what happens.
There's a great call out about the autonomous systems installed on our Nova C-class lunar lander named Odysseus. The process he's mentioning, Gary, is very similar to the one that we were preparing ourselves for at AOS, to where the lander has systems in place to recycle its antennas, to switch antenna pairs, and that was very similar to what we thought we were going to need to do after acquisition of signal. When we separated from the second stage of the launch vehicle, if we made it to a certain point, the lander was autonomously programmed to start taking matters into its own hands, and that was the information that our mission director, Dr.
We're not dead yet.
We're also not dead yet.
We're not dead. I feel happy.
Discovery, go at throttle up.
Hey, Yum Food. Thanks for gifting a sub.
And the key here, Josh, is patience. It's 5:34 p.m. Mission Director Tim Crane confirming that it could take 2 phases of 15-minute increments to confirm the status of the landing. So we could be here, and we'll stand by and monitor as Nova Controls continues to work this issue.
Yeah, tense moments inside of Mission Control with the most qualified folks.
We're picking up a signal from our high-gain antenna and transmitter. It's faint, but it's there.
Yeah,
so
baby, good news.
Stand by, folks. We'll see what's happening here.
All right, we're going to continue to stand by. Let's keep this camera on inside of Nova Control.
So why is that good news? Well, that means that the...
Waiting to keep Equasonics active.
Discovery, go at throttle up.
So, what does that mean? That means that, okay, so whatever came down on the moon has some type of power and is intact enough to transmit a signal. So that's good news. It didn't crash. It didn't explode. It's there. But they're not 100% sure why they're getting a weak signal.
We're still standing by the last call from Mission Director.
I mean, the worst case scenario there is that it tipped over. best case scenario, when it landed, it switched antennas, and they said they have 15-minute windows where it's going to switch the antennas in the event of a fault. It could have switched the antennas and you might need to restart something somewhere. I've seen crazier things. I've seen launch providers in the past power cycle an entire rocket fully fueled on the launch pad and then send it. It's happened before. You'd be surprised how much tech support tier stuff happens with spaceflight. It does. You just don't really hear about it. Thankfully, Intuitive Machines is pretty cool about broadcasting their communications loops, which is pretty sweet.
All stations, this is Mission Director on IM-1. We're evaluating how we can refine that signal and dial in the pointing for our dishes. What we can confirm, without a doubt, is our equipment is on the surface of the moon, and we are transmitting. So, congratulations, IM team. We'll see how much more we can get from that.
Like I said, it's intact. It's in one piece, or it's
Excellent
in
call
a big
from
enough
our
piece to
mission
be able to
director,
send a
Dr.
signal.
IM-1.
And over
Go
to
for
our
Prime.
CEO, Steve Altimus.
Yeah, if I could just pass on a few words to the entire team in Intuitive Machines at Superbab and here in the Mission Control. What an outstanding effort. I know this was a nail biter, but we are on the surface and we are transmitting. And welcome to the moon.
That's awesome.
Houston, Odysseus has found his new home.
An excellent call, and this is our team of Intuitive Machines mechanics and their families, their friends, everyone who has sacrificed so much to make it this far.
Stations.
I didn't hear what he said. I'm not sure, Alpha. I think they're just. I think it's just a straight antenna. Because it can't be a dish at the top or something because there's a solar panel up there.
How about that call, Gary? That was something else, a faint signal. Now it's time to work on refining that signal. But Dr. Tim Crane, our mission director today, making the call. Odysseus has a new home.
It shows the disciplines of the flight controllers in Nova Control. They waited until there was absolute confirmation that there was a signal, and then that was when they took the moment to celebrate. We saw that it wasn't just the individuals in Nova Control that contributed to the mission. The contributions to enable the success of Nova C's landing on the moon stretches far and wide.
Guys, a weak signal, honestly, a weak signal could be a bunch of different things. This is speculation on my part, so just chill. That roll component, that roll rate that the flight director or the flight dynamics officer was talking about, a roll component during landing, it sounds like it tipped over, but that's just me. I'm just a Twitch streamer. Let's wait for actual confirmation. You know, best case scenario, it just switched antenna modes and they need to just lock in on the signal.
Special for our folks, our employees, and folks watching at home.
Hey, that's right. With Nova C landing at Mount
onboard guidance.
Congratulations,
it's not
like
AI,
you said,
it's algorithmic.
Josh, are flooding into the teams that made this happen.
Nova C, the Odysseus lander, is using an algorithmic relative navigation control system. What does that mean? There's an algorithm that is analyzing pictures and laser range finding information and synthesizing that to plot a landing solution in real time. That's what relative navigation is. Humans use relative navigation all the time. Say you're driving in a parking lot and you see a parking space that you want. You look, you see the empty parking space. Get towards the empty move your car towards it, turn in, and park the car based off of what you see. That's what relative navigation does with an algorithmic computer. It's going to look, see how high it is off the ground with the rangefinders, and actually have downward-facing cameras image the terrain to avoid hazards, find a flat landing spot, and plot a landing solution to that spot. It's really trick.
All of that aced the landing of a lifetime. Today, for the first time in more than a half century, the U.S. has returned to the moon. Today, for the first time in the history of humanity,
see the camera
a commercial company, an American company, launched and led the voyage up there.
He runs NASA.
And today is a day that shows the power and promise of NASA's commercial partnerships. Congratulations to everyone involved in this great and daring quest at Intuitive Machines, SpaceX, and right here at NASA. What a triumph! Odysseus has taken the moon. This feat is a giant leap forward for all of humanity. Stay tuned.
All right, thank you, Administrator Nelson. Again, Nova C and the United States has landed on the moon at 5:23 p.m. Central Time today, February 22nd, 2024. Congratulations to Intuitive Machines on the successful landing. Science and data gathering is already underway and will continue for roughly 7 days on the lunar surface, activating payloads and gathering important scientific data to help ensure future successes in Artemis missions. For more about NASA's CLIPS initiative, visit nasa.gov/CLIPS.
Gary, it's been quite a journey.
Don't shut this cast
for all
off.
of us at Intuitive Machines. Thanks to NASA for the continued support to enable today's successful landing, and of course, everyone at Intuitive Machines, their friends and family who made all of this possible. That will wrap up our coverage of Intuitive Machines' IM-1 mission.
Josh!
Thanks for joining us.
Josh! What? Gary! Don't let him do that! Damn it. Oh, man. You are making me so angry. It's not a data feed, Parax. It's just a signal. So is it upright? I don't know. That's it. We're just on the moon. Never mind, we're not going to tell you about anything. Bye, I'll see you later. Deuces. So, guys, it appears that it is landed. It is in one piece. Now, the orientation of the vehicle, no idea. I'll be honest, and once again, purely speculative on my part, it sounds like it tipped over.
Discovery,
It
throttle up.
sounds like it tipped over. That call of rotation rates right before they lost signal means that if it was rotating when it was coming down, it could have cartwheeled around and tipped over. It's possible. If it landed on a slightly unlevel surface, if you're rolling, it's going to come down and it's going to flip. Now, just because they got a weak signal isn't absolute proof that the thing tipped over. It might just be a weak signal. Gary and Josh and the two gentlemen that were calling the cast, they did say that they do switch transmission modes. Then they switch antennas. They switch combinations of antennas. The Odysseus will do it automatically during descent if no signal is established. So honestly, it could have been there's 4 antennas for quadruple redundancy. The way it landed, the antenna could be pointed slightly off in a different direction. It might take some time to lock in on that signal. Just because you got a weak signal doesn't mean it's proof that it tipped over. It might be fine. But once again, if they had a roll rate during landing, and even if it's set down completely upright, your antennas might not be pointed in the right direction. Now, once again, it's going to basically sit there every 15 minutes. It's going to switch the combinations of antennas and transmit a signal. My guess is that it'll do that until they get a signal lock. If they get a signal lock and they establish a communications link to the lander, right, then we're good to go. That's what I was kind of hoping they would stream to, but that didn't seem to be the case. It's just a pre-recorded message and we're out. Okay. Let's say it did tip over. Is the rest of the mission screwed? No. This was a land. The big thing for the Odysseus lander was to actually land. Whatever the thing, whatever the reason, whatever happened, tipping over, not tipping over, antennas pointing in the wrong direction, weak signal, etc., etc., it's it is intact, relatively, on the surface, enough to transmit a signal, which means it didn't crash into the ground. It may have just tipped over, or, once again, roll component, the antennas could be pointed in the wrong direction. Worst case scenario would be that it tipped, but now that I'm really thinking about it, it was rolling. So if the vehicle's coming down like this, it was doing this. So here, let me use this really awesome 3D model of a starship. Now, don't get me wrong, this is not what just landed on the moon, but if it's doing this, right, when it's coming down to land, and the antenna is facing this way, right, the antenna that they're using is facing this way, and they expected it to land like this, and there was a roll component, the antenna's going to point in a different direction. But they have 4 antennas on this thing, and it's going to swap combinations of antennas. My point, not my point. What that basically means is that they could have 4 different antennas in 4 different directions, right? Because having 4 antennas pointing in 4 different directions is easier than having 1 antenna that can change its direction, that has an azimuth controller on it, right? Having 4 static antennas could help you. It could help with simplifying the design, and it adds quadruple redundancy. Once again, if the antenna was supposed to be pointed towards the camera, pointed towards you guys during landing, and there was a roll component, so the roll axis is this one, right? Pitch would be this, yaw would be that, right? 3 axis of rotation. If it was rolling during descent, especially during terminal, could have pointed the antenna over there, which would explain the weak signal. Also, it could have corrected, and that correction could have made it tip over, and the antenna's pointing in another direction because it tipped. Judging by what we heard about terminal descent, it may have tipped over, but my guess is the antenna's probably pointed in the wrong direction. I mean, I think that we could be utmost sure of that. If it is tipped over, it's definitely not pointing in the right direction. Or, best case scenario, it's just a little bit off of the expected transmission azimuth. Basically, the direction that the antenna is broadcasting in. But either way, they did get confirmation of the lander, albeit a weak signal. Once again, probably because the antenna is not pointed in the right direction. Albeit a weak signal on the surface of the moon. It's just a weak signal. So what news does that absolutely guarantee? That news absolutely guarantees that the lander is intact enough that its antenna and power systems are communicating. It is sending out a signal. So it didn't crash into the ground and explode. But it doesn't necessarily prove if it tipped over either. Either that or the antenna broke somehow. Yep, also possible. Yeah, when you get near the ground, you maybe if it landed just a little bit too hard, you could have bumped something loose. It could be that simple. Sometimes it is. And what makes spaceflight so freaking difficult is overlooking the minute things. Don't Michael Bolton. Don't screw up some mundane detail. That happens a lot more than you might think. It's really easy with the factor of difficulty that we're dealing with here to overlook a small detail, like not tightening down a wire or something. Stuff like that happens all the time. But that's, to compensate for that, that's why we do test missions, Michael Bolton from Office Space? Yeah, I always do that. I always screw up some mundane detail. What happened to that camera that was supposed to film it? Well, Tommy, once again, my guess is that the Eagle Cam is using the satellite as a relay. And if the satellite antennas are pointed in the wrong direction, then what footage we do get from the Eagle Cam eventually is you wouldn't be able to get it exactly, It wasn't live. Yeah, Cord. There's also that. It wasn't live. They're going to have to download that footage, and that's going to... Anybody that remembers being on the internet in the 90s, downloading a video is a real good way to not have any internet for a little while. i.e. it's going to take up a lot of bandwidth. There's not much communications infrastructure out at the moon. Missions like this are looking to change that. But yeah, believe it or not, you know, when we went to the moon in the 60s, there wasn't much out there either. That's why they put all the relay systems on the LEM, on the lander. The lander was your relay system. And all of the moon flights landed on the close side of the moon, so they were always in line of sight with the Earth. This being on the South Pole complicates things because you might not always be in line of sight. Can we expect some cool videos of the landing if it went well? Absolutely. You've got mail. Yeah, right. Yeah, bandwidth in space is, yeah, absolutely a thing. How in just in case you're wondering how they communicating with this thing, well, they do have their own ground stations, but they also can utilize NASA's Deep Space Network. Those are gigantic or up to gigantic 70-meter antennas. They're 70-meter radio transmitter. 70 meters is about 220 feet. It's a big dish. It's gigantic. Is the Lunar Reconnaissance Orbiter still active? Yes, Miguel, but the Lunar Reconnaissance Orbiter, I'm not 100% sure if it, A, is in an orbit that crosses near where Nova C landed, and B, if it's not in the right phase, then who cares? If it's over the North Pole right now, it's not going to help you very much. There's also the fact that the terrain is a complete unknown. Well, that's what relative navigation is all about, Tessa. It's supposed to plot a landing solution. The hazard relative navigation and terrain relative navigation systems are supposed to overcome that problem. Basically like how you'd look out the window on the lander and try to find a landing spot that looks flat, but you'll never know for sure. But hopefully they've trained their algorithms to recognize stuff like that. I bet you by tomorrow we'll know how the lander's doing. Bandit, let me put it to you like this. If we don't know how the lander's doing by tomorrow, something is very broken. If pitch and yaw control were fine, what do you think could have induced roll in the first place? Well, it's using helium as its reaction control system. They were using cold gas helium thrusters. At least that's what I think they said. I was in and out because I'm like, you know, still a little tired. Mac, you work at Langley and talked about it with an engineer and heard a background story. Oh, okay, cool. I like background stories. Colin with the 5-monther. Squish, sticky valve. Sticky valve. It could be, yeah, a sticky thruster valve could do it with a cold gas thruster. It could be that, you know, firing the thrusters while the engine is running, while the engine is gimbaled at 5 degrees could produce a momentary gimbal lock. It really depends on how well Intuitive Machines has tested their landing simulations. Usually they would test for some type of loss of control scenario, but you're never going to know until you actually do it. That's what risk aversion is all about. Can we do a replay of the final minute communications? They didn't. What's really kind of sucks, Professor, but hey, whatever. They don't want to show their stuff. They don't want to show their stuff, but they teased us. They showed the telemetry screens. If I saw the telemetry screens, I guarantee you I'd be able to tell you what that thing is doing. They had 3-axis IMU control, so I would be able to tell you exactly what it's doing. I know how to look at the nerd stuff. I can speak nerd, don't worry. Yeah, it is what it is. Snap, what's up, man? Yeah, it is pretty cool, though, right? As a simple mouth reader, not understanding much. Come on. Could you expand on the premise of future implications of testing at the moon's south pole? Well, there's craters down at the South Pole, and those craters are in perpetual darkness because the moon is tidally locked. One side of the moon is always looking at us, so there are certain craters down at the bottom, like in the very bottom of those craters at the lunar South Pole that haven't seen sunlight in millions of years. We figured out about a decade ago, the Lunar Reconnaissance Orbiter mission from NASA figured out that there's water down there. There's ice. The ice that hasn't melted because it hasn't seen sunlight. in a really long time. The ice has been there for a very long time. There's millions of tons of it. Tons. In those craters down there. That's why NASA's targeting the South Pole. You got water? Well, humans need that. That's kind of important. With water, you can do a lot. You can make rocket fuel with it if you really want to. Hey, Bob Rico, 38 months. Is it possible that they partially occluded themselves without it tipping over? I don't think it would plot a landing solution where there would be a hill in the way between them and mission control, Talon, but the relative navigation, maybe. To be able to answer that question fully, I'd have to see their relative navigation modes. I'd have to look at their algorithmic guidance software, which they're not. They ain't advertising that. They didn't even want to show us telemetry. Congrats on the landing. Yeah, Noswolf. Yeah. Partial success at the very bare minimum. Getting something down to the surface, as we've seen from other attempts over the past couple of years, is not an easy feat. The fact that they have even a relatively weak signal on the surface of the moon proves that they were able to get a semi-functioning probe at the very worst case scenario down to the surface. It's not an easy thing to do, guys, and I will say, Intuitive Machines, for their first try, they made it look pretty freaking easy. And not only did they make it look pretty easy, they're using an oxidizer mixture to land on the moon that's never been used before. Ever. No one's ever used liquid methane and liquid oxygen in a powered descent on the moon before what you just saw a second ago. So, a lot of big milestones. There's a lot of things to celebrate. That's a huge victory right there. They're also a publicly traded company, so they care a lot about PR. Yeah, absolutely. Did they mention how long the batteries will last in case the solar panels do not face the sun? Well, Finn, they have an angled solar panel up at the top of the Nova C lander, and eventually that thing will catch the sunlight no matter what the direction because it's angled. Eventually it'll catch the sun. So my guess is, if it was me, if you're going to engineer that, think about how long that thing, if you're at the South Pole of the moon, right? Think about how long a lunar one orbit of the moon is around the Earth, right? And then put your lander into a mode configuration that makes the batteries last more than a month, right? Like, that would, if we were able to surmise that just from that 30-second conversation, I'll tell you right now, that's exactly why that solar panel is curved, because no matter what the direction, it will get sunlight at some point, provided it didn't land in a freaking crater, which also could be the reason why we have signal obstruction, but who knows? We'll find out. Didn't Slim have a similar issue with that? One of Slim's engines exploded right when it was about to touch the ground. Right when it was about to stop and flip over and land. One of its engines popped. Yeah, so it had to compensate, and it compensated, so it came down kind of crooked. So when it came down kind of crooked and went to do that turnover maneuver, it actually made it come down like this, and then it flipped over like that and buried its nose in the sand. Kudos to them for even landing on a cryolander. It's a huge deal, Forge. That's probably one of the biggest accomplishments of this mission. They got a cryogenic lander, at worst case scenario, relatively intact on the surface of the moon. That right there, not even the Apollo missions did that. Not even close. The Surveyor program, the Surveyor probes that the Apollo program sent as precursor missions before humans went out to the moon used a 2-stage descent system. Want to know what the first stage of their landing was? Solid rocket booster. Yeah. Surveyors did the majority of their descent, which was a direct lunar landing insertion, so no circularization around the moon, direct to the surface, using 2 stages. First one was with a solid rocket booster, second one was with a monopropellant thruster. Well, RCS, basically. The SRB did the majority of the braking. They pooped out the SRB stage, and then they landed on the RCS. Yep. Some of them did not do that. Some of them failed miserably, but some of them worked. Only been done. Yeah, they're the only ones to do it on the South Pole. Hey, Arceus, thank you for the 19 months. I do appreciate it. Yep. Happy to see moon action again. I think we all are, Oprah. Absolutely. I'm confused as to why we can land on Mars, but have problems with the moon. Limey, it's... Well, one, we haven't decided to build anything to go and do this in about 50 years, give or take. That's the first one. I don't want to be, like, candid about this, but we land a lot more on Mars nowadays than we do on the moon. You know, after the Apollo program, we decided basically, oh, we've already been there, which is stupid. That's just an excuse. We've actually only scratched the surface of the moon. Seriously, that's all we've done. We've only scratched the surface, figuratively and actually. Apollo 17, the last Apollo mission that went to the moon in 1972, was the only mission out of all the Apollo missions to carry a scientist. Jack Schmitt, Harrison Schmitt. They gave him a shovel. He's a geologist, and they gave him a shovel, and they said, go dig a hole on the moon. So that's what he did. Dug a hole about this much. Guess what he found? Rocks that were orange. They were neon orange on the surface of the moon. We have actually only scratched the surface of the moon by maybe about 30 centimeters. So, yeah. The idea that, oh, we've already been there, that's a Bush League idea. Somebody used that as an excuse to defund the program. But that's 50 years in the past we're talking about now, right? So we've landed a lot more on Mars recently than we have on the moon. And here's the thing about spaceflight, okay? Spaceflight in terms of difficulty is like playing a game of Tetris, provided you don't beat the game and it actually freezes. Kudos to that guy. That was really cool. It's like playing a game of Tetris. Do you win at Tetris? Once again, that guy, not that streamer that actually beat Tetris, it played Tetris enough so it stopped, right? This analogy used to be great until that guy messed it up. You don't win at Tetris. You just get better at it over time. You're never going to win. That's what spaceflight is like. You're going to do a mission, and the mission's going to be okay. But all that does is make the next mission a little bit easier. So what am I trying to say? If you got really, really good at Tetris and then stopped playing it for a little while and then picked it up again, you'd still know the gist of what you're doing, but you wouldn't be as good as you were. That's spaceflight in a nutshell. We haven't been to the moon in 50 years. That's why everybody's having so much trouble with it, including us, who have arguably the most experience with landing people on the moon. Right? What about that time you won Kerbal? We don't talk about that. Ours has an atmosphere to help decrease speed to land as well. Rhino, I'm failing to understand how you think a heat shield arrow shell jettison to sky crane landing is somehow easier than just a straight PDI to the surface. I'm failing to figure that one out. Why do you think that's easier? I'm confused. That is not easier. That is that's a more difficult way to get to the surface in technical complexity, right? But using the atmosphere to your advantage is good. You probably should do that. We have far more experience with atmosphere than without. That's a good point. So, once again, guys, we, Intuitive Machines, they had a signal lock, albeit a weak signal lock, from the Odysseus lander on the surface. But a weak signal lock isn't exactly what they're hoping for. So, I mean, to sum this up, let's look at all the information given. They had a signal blackout during landing. They said that was normal. They did get a weak signal from Odysseus on the surface. So, what does that mean? They also mentioned a roll component on the vehicle during landing, right? Roll components aren't necessarily a bad thing, but they said they had an out-of-family roll component anyway, which means the thing was kind of spinning on the way down, like corkscrewing around almost. Does that necessarily mean that it didn't, that was why they were getting a weak signal? No, it doesn't prove anything, right? So, what do we know at the bare minimum? Well, the thing is intact enough that its systems work and it's broadcasting a signal. So at least we know at the absolute lowest common denominator that the thing is somewhat intact on the surface. That is a big feat in itself. That's really, really cool. That's a really huge accomplishment. You got to remember the Nova C class lander, Odysseus, fully cryogenic lander. No one's ever done that before. Not even the Apollo. Apollo used different fuels that were arguably easier to manage. This is a big feat. So, why are they getting a weak signal? That roll could mean the antenna isn't pointed in the right direction when it landed, or it tipped over. Could be either one. But it is relatively intact, which is great. It's intact enough to transmit. That still counts, baby. Close enough. Yeah, the tolerances for close enough with landing on the moon is not as large as horseshoes and hand grenades, right? But it's close enough. MSAT says the frequency jumped. Lander switch modes. Yeah, it's switch modes, Blue. It's cycling the antenna combinations to find the correct transmission azimuth to relock a signal. That's what they said. That makes sense. It's a smart way to do it if they don't get an immediate signal lock. That's really good guidance. Really good guidance in avionics coding right there. Flip up, it's down on the surface, intact enough to transmit a signal, but the signal is weak, and we don't know why the signal is weak. Antenna built by AT&T. I knew someone was going to do it, and Jay, I knew someone was going to make that joke. Lunar Node 1 LND-1 is the NASA mission that's on board Odysseus, Tessa. So if you see, here, let's go to see if the DSN, let's go, DSN now. Let's take a look and see if NASA has a lock on the vehicle. There's a website that you can go out and around called Deep Space Network Now, and it shows what NASA's radio antennas for long-range communication, so at Deep Space Network, what they're actually communicating with. We can see there's 3 tracking stations here, triangulated around the Earth. One's in Australia, one's in Goldstone, California, and the other one is in Spain, in Madrid. So, let's take a look. Dish 63, that's a 70 meter dish. It is communicating with one of the NASA missions, or it had a lock on the signal for one of the NASA missions. LN1 that's a NASA payload that's on Odysseus. So we look, so NASA's Deep Space Network, anybody that sends stuff outside of high Earth orbit, technically. Any country that sends anything past high Earth orbit can pay NASA to use their radio infrastructure to track stuff. So, for instance, let's look at Madrid 65. This is I think a 30-meter antenna. The 30-meter antenna is communicating with KPLO, Korean Pathfinder Lunar Orbiter. That is a mission that SpaceX launched last year. 54 is communicating with Capstone. That is a mission that was launched by Rocket Lab. That was an Artemis mission, and they're communicating with it. The Capstone satellite is in rectilinear halo orbit around the moon. It's basically pathfinding in orbit for NASA's future lunar gateway. And Madrid 56, another 30-meter, I think it's a 30-meter antenna, is communicating with something you guys probably know. Madrid 56 is communicating with James Webb right now. Yeah, pretty cool. Wonder what the rates are? Yeah. So if we look at California, California is communicating with BioSentinel. BioSentinel, I think, was a secondary mission. I'm not sure what mission that was on. I forget off the top of my head. Goldstone 25 is communicating with Juno. That's a deep space NASA exploration spacecraft. And this one's communicating with Soho. And these actually are the signals. This is just a UI that shows you the signals that they're transmitting in real time, which is actually super cool. Canberra here, the big 70-meter antenna in Canberra, which is actually brand new, might I add, is communicating with New Horizons, another NASA deep space probe. And Canberra 36 was locked on to Mars, if I'm looking at this right. Yeah, it was it had a signal lock. The last signal lock that it had, it's not transmitting anything, was with MAVEN, Mars Reconnaissance Orbiter, and Mars Odyssey. Nice, Ivo. That's cool. Greetings from Rocker. What's up, Adam? I think I found the problem. It's aliens. You see, asked me to say that it was aliens, W. I just lost a smidge of respect for you. Just a little bit. I was talking about landing a vehicle on a moon or a planet. Previous talks about us landing many things on Mars, but not on the moon. Mars is very complex to land on, no doubt, but landing on the moon is a completely different animal. Not being able to use parachutes, needing to use propulsion to land, I was just adding to your point. Oh, okay. Thanks for the clarification. Erudite, what is this? This is a link from John Krause. Owned. Man, that guy had a lot to say after that, Erudite, huh? Hey, Crustacean. 28-month resub. Pinter Smidge. Midge. You know what I'm talking about? James Webb's currently transmitting at about 28 megabit. So uploading today's data by the looks of it. Yep. Could kicking up lunar dust while landing give a weak signal? It's possible, 7, but the dust would have settled by now. Yeah. The fact that they didn't have signal lock 15 minutes after their expected landing, and we saw Odysseus switch antenna configuration modes 15 minutes after. Well, that still proves that it's intact on the surface relatively. It might be just on its side. Or it's turned. The antennas are pointing in the wrong direction. Eventually, it will find a combination of antennas to use. Out of the 4 that are there, there's only so many permutations that you can do with that. Eventually, it will find one that works. Or, we just track a weak signal instead. MSAT DL update from 77 minutes ago says there was a frequency jump. Yep, it's still cycling. So it's still, the lander is automatically going to test all the different permutations of the 4 antennas on board. So like antenna 1 and 4, 1 and 3, 1 and 2, right? It's going to test all those, or, 2 and 1. It's going to test all the different combinations to see if it can get a signal lock. Hopefully it's just in a crater or a shallow valley or something. Biopotential studying radiation damage on organisms. The one on board being yeast in a heliocentric orbit that launched on Artemis 1. Yeah, that was a CubeSat. Yeah, there you go, Zay. Cool. BioSentinel. Yeah. Okay, gotcha. All right, Kill. See you, buddy. Grammar is hard. Goonhilly is retreating. Goonhilly is retweeting success. Retweeting? I thought I saw a putty cat. Their control room picture doesn't seem that happy. Let me see. Once again, guys, if you ever watch space missions, right? You ever watch mission control during a high-profile space mission, launch, landing, wherever, they don't. If they can't show you the spacecraft, they usually show you a picture of the people that are controlling the vehicle, or at least monitoring control of the vehicle. If you see people in mission control do this, or this, or this, you got a big problem. That means something went wrong. If you see people do this, if you're seeing people do this, right, finger up on that, I'm telling you, this is just, I've watched so many of these dang things. So many launches, so many landings. If you see something like this, or like that with the finger on the nose like that, that means the mission hasn't failed, but the thing is doing something that they didn't expect. And I'll tell you, when we saw Intuitive Machines Mission Control right before they cut the cast, one of the guys was doing this. If you see the not like this thing, that means it's gone. that means it's broken. Now, we didn't see any of this, and we didn't see any of that. All right, we didn't see any face palming. We did see this, which once again, that jives extremely well with what the casters were saying, meaning they have a weak signal, which is not what they were expecting, which means it did something that they didn't understand. What's it doing now? Right? This works 100% of the time, every time. Doesn't even make sense. Yeah, let's see what these Goonhilly guys look like. Oh, yep. See? Dude, like clockwork. See? What the heck is it doing? Well, see this guy? Well, that's not right. See? See what I'm saying? Look at everyone in this damn control room. See what I mean? These are the guys controlling the ground station. Well, that's not right. Dude, finger on nose every time. Without fail. Every time. If I don't have the telemetry, the flight controllers will tell me the telemetry. It's easy to see it. Yeah, that's not what it should be doing. Yeah, that's not right. Why did it do that? They're all doing it yellow. Dude, this happens every time without fail. You need to write a paper on micro expressions in body language and mission control. I've cracked the code. Where's this Hermano guy? Oh, boy. Yep, what's it doing now? Yeah, one of the controllers in their mission control room looked up at the camera and said something like, I don't know what that was about. I don't know what body language that is. I can't tell if you're excited or pissed. So when is the landing supposed to happen? It already happened, Crafty. The landing was about a half hour ago. I think it was just joking. Yeah, maybe, dude, maybe. But they had a telemetry blackout during landing, which is pretty normal for pretty much par for the course for landing on the moon. It kicks up dust, and the dust stays there because it's 1/6 the gravity, so everything is, going in slow motion, so to speak, right? So, they got a signal lock, Crafty, so it is intact on the moon. The question now is how intact. And that's what everybody's trying to figure out right now. That's as much information as we got. It is intact enough to be able to transmit a signal. And like I've been saying, the best case scenario here is that it just settled a little bit or rolled a little bit. They did say it had a roll component during landing from the last known, right before the telemetry cut, like right before it landed on the surface. It had a little bit of a roll component. So, like, I'll use this Starship model, right? It was doing this during landing. So the best case scenario is that it's upright, intact on the moon, and the antenna's pointing in the wrong direction. Worst case scenario, it fell over. If the worst case scenario is it fell over, but it's working just fine, that's still an absolute win. I see this as an absolute win. That is absolutely a W. That's a dub all day. A win is a win is a win is a win. How about this one? The roll during landing was enough to slap a leg off and bend it, and it's upright and just leaning over. Goalie, are you suggesting that centrifugal force was enough to snap a leg off? If that was the case, I wouldn't be trusting those landing legs for anything. I don't think no, highly unlikely. Landing legs are the strongest part of the vehicle. If the thing rolling at 8 degrees a second radian which is basically 8 degrees a second radian, that's like maybe 20 RPM. If that's enough to shear a leg off, yeah, no. Maybe, if it contacted the ground a little funny, maybe it could have overloaded one of them, but I highly doubt it. Those legs are those legs are rated for probably like at least 2 times the load of anything that would be encountered. Anything that be encountered. Why wouldn't you engineer them to do that? Obviously, you're taught. We have to deal with mass, right? Because mass is the enemy of delta V, right? More rocket on your rocket, less fuel on your rocket means it's not going to go as far. Absolutely, but the legs are kind of mission critical. 2,000 kilos alleviate. Or thoughts on if it bounced? I don't think it bounced. Spaceman. I mean, I don't think. That's not what my gut's telling me. It's either tipped over or the antenna's pointed in the wrong direction. Or because it's tipped over, the antenna's pointing in the wrong direction. Guys, antennas have convergence distances, okay? And depending on the geometry of the high gain antenna and the frequency that they're communicating on, high gain is usually high frequency. High frequency transmissions are basically for shorter distances, like short band radio, ham radio, short band. Makes sense? Citizens band, CB radio. Anyway, this is a little bit different. This is more like television signals from back in the day. They're really for shorter distances, but I don't know. If it's a parabolic antenna, then you're going to have a convergence distance, and the convergence distance is entirely dependent on how much power you put through the thing. Hey, Spaceman, 7-month resub. Yeah, I know. Chat delay. I got you. Yeah, it's not like a short band. It's more like VHF or UHF. So rabbit ear signal for the people that understand what that means. Rabbit ear antennas. 8 degrees a second rotation. It's not 8-degree rotation. It's 8 degrees of rotation per second radian. Tessa, different. That's not the same thing. You need to use radian to figure out RPM. If I had to guess, it's not 1.3 RPM. It's a little bit higher than that. NASA didn't want to say anything negative, then they would be liable. Liable for what? They paid Intuitive Machines a lot of money to do this mission. Why would they be liable somehow? I'm confused. This isn't court, Silver. You know what I mean? 3D model to show the antennas. Ooh, Foz, where'd you get this one from? Oh, it's on Sketchfab. All right, let's take a look. Let's see if we can see where those dang antennas are. Yeah, parabolic. That's a parabolic antenna. I'm not sure if that's the right one though, but that would, if it was rolling and that was the antenna that they were using for high frequency communications, it's a fixed antenna. It doesn't move, so that would very much explain why they're getting a weak signal. 8 degrees a second radian is 76.36 RPM. Yeah, that's the payload. Yeah, they said they had 4, so I don't see 4 of those things on there. If I had to guess, those might be the antennas right there, but I'm not 100% sure, and I don't want to guess. But there is 4 of those things, and they're all pointed in different directions. So, those are still fixed. If those are them, that's still fixed antennas, and they're still... It's probably alternating combinations there. All right, let's check on the DSN here. Let's give it a quick refresh. Yeah, at least, so here's the other thing, guys. They said 8 degrees. Now, I'll admit, I don't know what that means, okay? I know about degrees a second radian, and if he was asking the flight dynamics officer what the rate was, usually rates on spacecraft are measured in degrees a second. Degrees a second radian. Right? That's usually what they're measured in. If Intuitive Machines is using some type of different measurement, like what Tessa said, if they're just using degrees a second, not degrees a second radian, which is weird, I'm not sure anybody does that. But if they had their systems configured to do something like that, well, 8 degrees a second is not that much. I'll admit, I am assuming they're using degrees a second radian because that's what everyone uses. That would be like going out up to somebody in the United States, you know, a cop pulling them over, right? And going up to a driver in the United States and saying, you were going 200 kilometers an hour. You have any idea how fast that is? The person would look at them and say, no, I don't. Because we use miles an hour here, sir. And now that I said that, there's going to be 1,000 people in here weighing in on what they think of our measuring system. Please, type it up. Type it up. Hit the enter key. Please, I want to hear it. Your call is really important to us. Please stay on the line. No, I don't. I'm not going to lie. I don't care. I'm sorry. I thought this was America. No, degrees a second radian is what. That's the standard for rotation rates. Yeah. There you go, Tessa. You like freedom. You should. I told you to keep typing. Yeah, EJ drinks your unit conversion. Tears. I was thinking the other day, if you fly at high speed around a black hole for 1 month, 1 year will pass on Earth. But is the opposite true? If you're in a void and not moving, Violent, you want to look up time dilation. I don't know how that works. I deal with our regular plane of existence. Yeah, right. So yeah, you want to get freedom because you're Scottish, right? So burglar alarm, right? I think I read that they're using their own private communications network since they want to reduce strain on the DSN. That is what they said, Phil. They're using a private station in Goonhilly. I'm pretty sure it's the same one that SpaceX uses, but NASA still locked the DSN on their mission that's on that lander. And if they're getting a signal lock from that, from Land 1, I think they're not communicating with it anymore. Also, the DSN is expensive, yes. Mm-hmm. Why not use bananas per second as a unit? Rafa, this is where people are going to hate me. I don't care what measurement system anyone uses. That is up to the person that's managing the project. It's also up to the person managing the project to make sure that everyone is using bananas per second. Because if somebody is using meters per second and not bananas per second, that's a project management problem, not a measuring system problem. Okay? As long as everybody's on the same page that we're using bananas a second, which technically is a flow rate, not a unit of measurement, unless you're using standard ULA bananas or chrome bananas like that one. As long as everybody's on the same page, you're good to go. Probably, Phil. That makes sense, dude. And thus you get issues where planes get filled up with the wrong quantity of fuel. Once again, that is a programmatic management issue, Drummer. That has nothing to do with the measuring system. Why does that mission have 3 different names? Nova C, IM-1, and Odysseus. IM-1, Intuitive Machines 1, is the name of the mission. Nova C is the class of lander, Jim. And Odysseus is the name of the lander. Odysseus is a Nova C lander that is flying on the IM-1 mission. Just like how Dragon Endeavour, which is a Dragon 2 capsule, flew the DM-2 mission in May of 2020 and returned U.S. astronauts from American soil back to the space station. Make sense? Well, bananas a second could be another way to do expanding an area, like an arc second, if you use the surface area of bananas as the base unit. You friggin' nerd! Get the hell out of my chat! Go nerd somewhere else! No, I'm just kidding. You can keep nerding in here. It's fine. Furlongs per fortnight, please? Neon, now you just got to get everybody to agree with you, which they're probably not. Hoagies are an accurate measuring system. By weight, app state, sure. Not by length. Circuit boards commonly use ounces of copper for copper layer thickness. There you go. I prefer smooths. Yeah, you're killing me, Smalls. Bananas a second. Yep, makes sense. I just don't remember them ever being clear on the nomenclature. They seem to use them interchangeably. Yeah, Jim, that's probably just the commentator, Josh, just kind of feeling out his commentatoriness. I've never seen him commentate a launch before that. But whatever that guy did before he had a job at Intuitive Machines, hold on. He's a damn good commentator. That's what I'm trying to say. Hold on. Madrid 63 has a lock. Hold up. LN1, Lunar Node 1, is a NASA mission that's on the IM-1 lander. That's on Odysseus. It has a lock. It's not transmitting, though. That thing just ticked back on. Hold on. AOS mod check. Mod check. Mod check. Click more details below it. More details. Setup, teardown, tracking. Okay. If this thing starts doing this right there, we're good. That's a pretty good indicator of what's going on. We'll see. We'll see. Also, we should keep this Goonhilly tracking station Twitter account active here. Goonhilly. Isn't Goonhilly in Cornwall? That's the southwest part of the UK, yeah? Yeah, dude, once again. Hands on face. Hands on... Oh, what's it doing now? You are a goon. Yeah, well, you're a hilly. Roasted. Alright, let's keep that going. Let's keep here. Let's see what we got. Didn't they say the search time was up to 13 hours? Yeah. Yeah, once again, this is showing what NASA's Deep Space Network, which is 3 ground stations that are designed for communicating with stuff higher than 30,000 kilometers that way. Anything outside of high Earth orbit, or a better way to say it would be anything in deep space outside of the outer fringes of Earth's magnetic shield, uses ground stations to track. Why? You're going to need something very powerful to communicate with something out at the edge of the solar system. So a ground tracking station will give you the power. At that, and launching a 70-meter antenna up into space is frankly not something we can do just yet. That should change soon, though. That'd be really nice. So these are the 3 triangulated ground stations. When I say triangulated, each of them are a third of the way around the globe. Madrid, Spain. Goldstone, California. Canberra, Australia. Oh, nice, John. That's cool. We'll check that out later. I'm kind of... Oh, there's the emails test. Nice. Cool. The future is laser communication, which NASA is actually working on, Cartesian. Yeah, they have... If I'm remembering correctly, they tested laser optical communications out near the moon. But yeah, that would be nice. That'd be nice. Did we land? Hey, Odie. So... We're not sure. I'm not sure, at least. I don't think Intuitive Machines is sure, at least, at this time. What I can tell you is that the thing is down on the surface, and I will say it's intact enough to be able to send a signal, albeit a weak one, back to Earth. If we're watching NASA's ground tracking stations, or deep space tracking stations right now, and Madrid 63, which is a giant antenna, has a signal lock on Lunar Node 1. LN1 is a NASA mission that was flying on the Odysseus lander. They're set up, tear down, and tracking it. So it means that they're locking in, and we're looking for a transmission here. You can see the other dishes around communicating with different payloads around around the solar system, like James Webb, for instance. Madrid 56 is talking to James Webb right now, which makes sense because James Webb is at, what is it, Earth-Moon L2? It's orbiting around the Earth-Moon L2 Lagrangian point, or is it Earth-Sun? I forget. Somebody's going to have to refresh my memory. I think it's Earth-Sun L2. So if it's Earth-Sun L2, that just happens to be a coincidence that Earth is pointed towards the moon and James Webb at the same time. Yeah, it's Earth-Sun. There you go. Come on, we're looking for the squiggly lines, dudes. Right now, it's Schrodinger's lander. Yep. So once again, there's this thing with parabolic antennas called convergence distance. So you have a transmitter right here, and that transmitter shoots a signal downwards at the dish, and the dish reflects it. Because the antenna is bowl-shaped, it'll eventually it'll take a signal that's transmitting outward, basically like a hemisphere, and because the antenna is bowl-shaped, it'll make the signal converge. Here, I can show you. Hold on. Give me a moment. Once again, these types of antennas are called parabolic antennas. So, setting convergence distance basically depends on the frequency of the transmission, but that also depends on how much power adjusting the power will get you a different convergence distance. Basically, the signal that it transmits out, it's transmitting in a cone, right? Because it's bouncing off the antenna. The antenna is bowl-shaped. It's projecting that at the antenna, and it transmits it in a conic shape, right? Depending on power, depending on the azimuth, depending on a bunch of things, you ideally want to get, because it's cone-shaped, you want to get the convergence, you want to get the payload inside of the convergence on the radio waves. Give me a second. Now, don't get me wrong, I'm not the best at radio, so that was a very simple explanation. I could probably explain that a little more in depth here. Just give me a moment. They're working on it, Salyut. You got to start somewhere. How are we looking on the landing? It's intact on the surface, Spoon. The real question is how intact. The antennas aren't pointing in the right direction. That could mean a bunch of different things. It could mean it tipped over on the surface. It could mean that it just twisted a little bit during landing, trying to settling on the lunar surface. It could have sank a little bit. The antenna could be pointed in the wrong direction. These antennas are high gain. This is what I was talking about. This is why, if you're old enough to remember putting rabbit ear antennas on your TV, even moving them just a little bit was the difference between static and getting a clear picture. Because you're using high frequency communications, it's very directional. So even if the antenna is off by a degree from where they expected it to be, Spoon, because the moon is 250,000 miles away, that 1 degree of difference could be the difference between pointing your antenna at Australia or pointing it at Canada. You know what I mean? So worst case scenario, it settled in the ground and the antennas are just a little pointed in the wrong direction. Or best case scenario. Worst case scenario, it fell over. But it is intact on the surface. She's there. And it's intact enough to transmit a signal, which is good news. A surprise to be sure, but a welcome one. Do they have low gain? I don't know, to be honest with you. Hang on one second. I'm still trying to find a picture of like how parabolic antennas have convergence. Long story short, I can't, whatever. That conversation ended anyway. You got to kind of keep it going when you're streaming. Long story short, a parabolic antenna, they have to get the power right. And because they have to get the power and the frequency right, that could mess with the convergence, and it could especially screw with it if it's not doing, if the antenna isn't pointing where they expected it to be pointing. So once again, NASA is trying to transmit to LND1. They haven't transmitted anything, but they kind of, well, I don't think they have a lock either technically, unless they're transmitting that, which is contrary to what I said a little bit earlier. Sorry, I wasn't expecting to talk so much about radio waves today. We haven't, but there was enough information given to know where to look to tell if the thing is intact or not. Lunar Reconnaissance Orbiter already flew over the pole, so we'll have to wait. Is anything communicating with LRO? It's very clear that Spain is pointed towards the moon right now because of KPLO and Capstone. Those are 2 lunar missions right here. That one's from Korea, and that one's a NASA mission. Yeah, so Eddie, they do have, I think this means they have a lock on it, but they're not transmitting. Check NASA eyes. This is NASA eyes, dude. Anyway, guys, I'll be back 1 second. Just keep an eye on the screen. Give me 1 moment. Okay, I just woofed that slice of pizza. We can't hear you. You can't hear me typing in chat? I'm confused. Patrick, I'm confused. Yeah, yes, I am. All right, so let's keep an eye on the Deep Space Network. We'll do this for a little bit longer. We should be getting up to the point for another antenna combination change on Odysseus, so we'll see. Clickety-clack, EJ is back. Oh, Riv, there's a live stream? There's a live stream of AMSAT? All right. All right, I'll admit I am not 100% sure what I'm looking at here, but we'll see. Why is Capstone's orbit so weird? Zymus, Capstone's orbit is the near rectilinear halo orbit is a type of orbit that is that maintains constant line of sight with Earth. It's a very interesting style of orbit. Not something that you would be able to replicate in KSP without Principia. Long story short, it uses lunar precession to adjust the longitude of ascending node on its orbit every time it does one orbit around the moon. The idea is that because the moon is kind of facing Earth the entire time, the moon is weighted. It's denser on one side than it is on the other. The near side of the moon is denser material. That's why the moon is always facing us. Like, think a pendulum. If you have a pendulum, right? You have a weight at the end of a string, it's always going to point down towards the ground. Moon's like that, but unlike the pendulum, it's going fast enough to stay in orbit, right? The near rectilinear halo orbit utilizes this lunar gravitational perturbation in the form of precession to be able to stay in constant line of sight by adjusting its orbital plane basically to follow the moon's orbital path, maintaining constant line of sight to Earth. Capstone is a satellite that's in that orbit, and it's a NASA mission. Capstone was a commercial lunar payload services mission, just like the IM-1 mission is. And it's used to basically figure out what the right orbit would be for Gateway for future Artemis missions to be in. Pretty cool, huh? Oh, great, a waterfall. We got sonar text here, yeah. Yeah, Skogs, that's what I'm worried about. I think best case scenario, the antenna is pointed in the wrong direction. In which case, the lander will keep using different types of antennas. It has 4 antennas on it. It'll keep using different combinations of antennas until it finds a signal lock. So that's the best case scenario. It's just a matter of time before, we have two-way communication with the thing. Right? Yep. This guy right here, I think. I mean, they wouldn't have put the mouse over it for no reason. I'm not 100% sure what I'm looking at here. Or I think the worst case scenario is that the thing tipped over. Once again, either one of those things are just an opinion. I'm not 100% sure. There's no way to know until we get a lock on the signal. That is mode switching, not signal. Okay, yeah. Drax, if you could just tell me instead of being, putting the ellipse at the end. Yeah, that'd be good. I've already said multiple times that I don't know what this means. You don't need to correct me. Just tell me what's going on, my brother. If it's tipped over, is that good game or can it be saved? Iglulik, having it tip over isn't the worst thing. you could still get science out of it, because remember, this is a mission to test the landing system amongst anything. Everything else, there are other NASA missions on board, like Lunar Node 1 and Eagle Cam and other things, right? Like, there are other things, but I think the primary goal, the biggest goal of this mission is getting the thing down onto the surface intact. And even if it's tipped over, that still means it's on the surface intact. That's still a win. That's a W. Thanks, Geek. I have MSAT up there, and yeah, see the blip right there? That's almost the frequency that was there. Like, I don't know what this means, to be honest with you, Aspef. I know this is frequency, obviously. That's frequency, and I think what this waterfall is showing the transmission at that frequency, I think. I didn't even know this was called a waterfall until someone said it in chat, until John said it in chat, maybe a minute ago. That's the transmission over time. Got it. The color just shows the intensity of the frequency over time. Got it. Okay, cool. Straightforward enough. Let's go back over here. Do we have anything? What's that frequency then? So 2257, 2259. All right, so where's that over here? We're looking for a signal right here, right? There are other screenshots, forget from which portions of the mission, but show the signal with better signal to noise ratio. Is that what all this stuff is? Background noise, Aspie? 135.652 megahertz. Okay. Looks like the stocks are trending up. Yep, diamond hands. Hodl. Here, let's go back over here. You said there's other places to look. Oh. Oh. That's what that's supposed to look like. Hold on one second. There's always, yeah, that's all noise and possibly reflection of the lander center frequency. That's all noise, background, and signal. The signals are what stand out as vertical lines. Yes, mostly background noise at the moment. All right, cool. Thanks, guys. Yeah, no, sometimes you got to teach me, right? I'm not the best with radio, I'll admit. Oh, that's what we're supposed to be looking. That's what we're supposed to be looking for. Okay. And oh, am I looking at this frequency over time thing and seeing this correctly? That's what a weak signal looks like. This should be a line. Here, let's check DSN now. They still have a lock on it, but no transmission. And this is what I mean. Now, what I do know enough about radio to know that if the antennas are pointed in the wrong direction, you might need to adjust your antenna's azimuth to intercept this. Intercept? You can't intercept a radio signal, can you? Not like that, but it's because it's pointed in a different direction. You might need to reconfigure the antennas a little bit. I think that's what everybody's trying to do right now. Yeah, think flashlights. Yeah. I got you. That is a weak signal. Yep. It needs to be aimed correctly. I could explain this more detailed, but it's also 3 a.m. Yeah, I got you, Aspie. Thank you for letting me know. Everybody, thank you guys. I appreciate it. Yeah, I asked just don't be a dick, because I have no idea I don't know what this means. But I can learn. I'm not stupid, not all the time. But, I mean, you know what? Forget what I just said. Teach me. Forget that part. No, the front fell off. Well, is that normal? No, pass this part. In fact, never play this part again. The more I learn, the less I know. Deviator, that's how you know you're actually learning. Because if you learn something and you think you know more, you didn't learn good enough. Most of the time with anything that has to do with any type of science or engineering, the moment you think you got it figured, you're wrong. Paper patching, state of the art. Every time I learn something new about rocket science, it adds to a database in my head of expanded rocket science nerd stuff. And the bigger that database gets, the more I realize I know dick. Yep. That's how you know you're learning good. Because if you think you got a good grasp on this, nobody does. Yeah, that means you're learning. That means you're doing it right. That means you're doing it right. Once you learn something, you learn more questions to ask. It's true. It's the dang thing about engineering. Like I said, it's like playing Tetris. You never win. You just get better. And if you're not getting better, you're probably getting worse. Like, you just got to keep learning. When you learn something new, old info goes out the other end to make space, though. What is it, a hard drive? The people who know the most understand that they truly know nothing. Yeah, that's right, man. That's how you know you've learned. That's how you know you've been learned real good. Okay. Let's get rid of that. Any word from Goonhilly here? That was 49 minutes. Let me see if we have intuitive machines up here.
Discovery, go at throttle up.
Let's bring up their tweeterers. What are they saying? Odysseus has a new home. Yeah, how long did you have that one teed up? I'm sorry. You always think about what you should say, right? This was 5 hours ago. 1 hour. Odysseus has a new home. Nothing since. All right, let's go back over MSAT. Anything from this? 71 already from S. Thank you very much. Here, let's just get some background tunage. Thanks, S. Love you, buddy. I'm going to keep refreshing here for a little bit, and we'll see what's good. Yeah, our brains are cheap 2 terabyte USB flash drives. All right. So, once again, in case anybody missed it, the lander landed. They caught a signal from it, but the signal was really weak. But that's good and bad. Good news is, the lander is on the surface, somehow, not unknown state, but it was intact enough to send a signal, right? And we caught a bit of its transmitting signal. So congratulations to Intuitive Machine in that regard. That's fantastic. Now here's the thing. Signal's weak. That could mean a couple of things. The antennas could have gotten damaged during landing somehow. Maybe they did say right before the landing that the vehicle encountered a slight roll rate, which means the antennas, you know, if it rolled a little bit, the antennas are fixed. They're not omnidirectional. They don't turn like that thing, right? So that means that the antennas could be pointed in the same direction and it could be intact on the surface. That's the best case scenario. The worst case scenario is that it landed and tipped over, in which case the antennas would also be pointed in the wrong direction again. But I would contend to say that they probably wouldn't even gotten a weak signal if the thing had tipped over. But who knows? That's why I'm watching all the tracking stations here and watching Intuitive Machines to see if anybody gets a frequency lock here. So we'll keep doing this for the time being. That's the Eagle Cam, Shaw. It chucked the CubeSat off of itself in the last 30 seconds and that CubeSat had a camera on it pointing back at the lander to get it landing. We're not going to get that footage right away. That footage wasn't transmitted, it was recorded, and it will be transmitted later. You're not going to get that footage at all if you don't get a signal lock. Yeah, Silver, settling in the lunar regolith, it could have landed just fine. Settling in the lunar regolith, it could have just tipped a little bit, in which case, once again, the antennas could be pointed just a little bit off. Even if they're just a little bit off, a little bit off on the surface of the moon, all the way over there, equals a big difference down here on the surface. So, I think what's going on right now between all the ground stations here and NASA with the DSN. So NASA is trying to communicate with LN1, Lunar Node 1, which is a payload that's on the lander. I think they're all just trying to figure out the right communication and right azimuth and elevation to get a signal with the lander. Landed on a boulder? Well, Spaghetti, it has systems on board that are specifically designed to not do that. That's what relative navigation is all about. Is this the first time they've landed on the South Pole? Smoke, this is the first time anything that we've made has been near the South Pole. Anything. Is there no way to take a picture from space to see it? The closest thing, Al Davis, would be the Lunar Reconnaissance Orbiter. The Lunar Reconnaissance Orbiter is a good ways up off the surface. A couple 100 miles because it's orbiting, right? Even then, an LRO picture is not going to be like a super high-def image because it's 200... I forget what the Lunar Reconnaissance Orbiter's orbit is. I'd have to go look. It's higher up off the surface. It wouldn't be good enough to get a good picture. But the Lunar Reconnaissance Orbiter can take pictures of the surface. They're just, once again, it would be like you taking a picture at 30,000 feet of a license plate with a camera on it flying on an airplane. You'd need a really freaking good camera to do that. Now, if I'm remembering correctly, the Lunar Reconnaissance Orbiter is a little higher than 30,000 feet off the surface of the moon. However, you know, you're taking a picture at 30,000 feet, you know, on your airplane on Earth, there's going to be some gas diffusion because gas diffuses light. Right? That's why the moon and the sun appear to be different colors when they rise up over the horizon or set over the horizon. Because you're looking at the moon through more atmosphere this way than you would straight up, right? So gas does diffuse light, we know that. So the Lunar Reconnaissance Orbiter has the benefit of having nothing in between it, nothing in between it and the surface. So the pictures are detailed, but they're not, let me put it to you like this. We wouldn't be able to get a detailed picture, but what we would be able to see, the Lunar Reconnaissance Orbiter will be able to tell if it tipped over. It'll tell. Yeah, it'd be dead giveaway. Because you'd see the ejecta from when the thing turned sideways, and you'd see scorch marks on the ground going sideways instead of just basically what looks like a crater. The PE is 20 kilometers, AP is 165, just double checked. Yeah, 20 kilometers up. That's 20,000. That's what, 20,000 meters? what, that's 60,000, 60, 70,000 feet off the surface for the people that measure distances and body parts. Has there been no word from Intuitive Machines? Nothing from them just yet. It's somewhere on the South Pole, 7. I'm not exactly sure where they landed. And I'm not sure they even are exactly sure where it landed. I can give you the region. I'd have to go back and look at the cast, though. Check the DSN. Got it. Switching back. Oh. Madrid 63. It either fell out of phase or they're trying something different. It might take 02-26 2300Z for the solar wind to die off before we get a minus 90 decibel signal. What is the expected time of the touchdown? Greg, it already landed. It landed and we got a signal from it, but the signal was extremely weak. So I'll say it again just in case anybody's wondering. Greg, what that means is that it's intact enough on the surface to transmit a signal. Now, what does intact enough mean? Best case scenario, settling onto the soil, maybe if it's settled and twisted a little bit, it could have pointed an antenna in the wrong direction. Now, the lander has 4 antennas on the top, and they're all pointed in different directions. And what it'll do, what it was designed to do, is after it registers a landing, it's just going to switch between different permutations of antennas every 15 minutes to try and get a signal lock, to try and establish communications with Earth, right? So that's the best case scenario. The antenna, it just settled a little bit. The antenna's pointed in the wrong direction. Worst case scenario is that it tipped over. But I would still consider this a victory. It's intact enough on the surface to transmit a signal, meaning it didn't crash. If anything, it may have landed and tipped a little bit, or, like it settled or something. It is intact enough to transmit a signal. That's a W, dude. Big W. Big win for Intuitive Machines. To even get near the damn thing, to even get near the surface of the moon is a hell of an accomplishment. But to land on the surface intact enough that your payload is still operable, worst case scenario, is insanely difficult to do. And you got to remember, this is a private company. This isn't a government. This isn't like Chandrayaan with India or Chang'e 5 and U2 with China, or Luna 25 with Russia, which Lunint 25. Yeah, that thing didn't work. This is just a private company. That's a good point, Oculus. They're not governments. This is a private company doing this. So, once again, we'll keep monitoring the networks here and for a little bit longer, and we'll go from there. Looking at some old GSFC charts, LRO is in about an 85-degree inclination by now. It would have probably seen IM-1 eventually, but probably not for a while. I think, Ivo, Occam's razor, right? We don't have a picture from NASA's Lunar Reconnaissance Orbiter because it hasn't flown over it yet. We would have seen one by now. NASA isn't about to not tell everybody that they just landed, that Intuitive Machines just landed a NASA-sponsored payload on the moon. They're not about to not tell anybody about it, you know what I mean? I think that's a reasonable extrapolation of logic there, so. Yeah, but, as you say, technically it's publicly traded, but once again, tone deaf to the context of the conversation. The implication is that it's not a government entity, it's commercial. But, keep being tone deaf, it's cool. We still love you. Still planning a nap before Starlink? I'm curious here, Bree. I kind of want to sit here and wait a little bit longer, but also the toothpicks were fantastic. Those freaking toothpicks work. I don't know what the heck. I don't know what the heck was in those things, but yeah, no, I got a second win there. Also, a moon landing probably gave me a little bit of an adrenaline rush, but yeah, we'll see. Madrid just came alive again here. Madrid just reconfigured for Voyager 1. I can't help but have one burning question. How do we land on the moon 60 years ago or so? It seems so difficult. Ryo, I made an analogy for this a little bit earlier. That's a good question, dude, and I think it's a very pertinent question. The analogy that I made is that, and the analogy that frankly I've been making for the better part of a decade, is that spaceflight's like Tetris. Okay? Think about it. It's like Tetris. You don't win. You get better at it. And the only way you're going to get better at it is if you keep doing it. When's the last time we landed on the moon? Last powered descent from any U.S. entity on the moon was December of 1972. That was 52 years ago. Now, say we keep going with the Tetris analogy, right? Say you get really good at Tetris, and you get good enough at it that you break the game and you beat Tetris technically, right? Then you take a break. First time you go and pick that thing up again, are you going to be able to get the high score? No, absolutely not. It's going to take some time to dust off the cobwebs. Now, with all that being said, the fact that we did what we did in less than a decade just shows you how ballsy the Apollo missions actually were. There were risks. Absolutely. Big risks. Big risks. Think about it. The entire goal of the Apollo program was essentially go fever. Land in this decade, right? Land before the Russians do. Think about it. The whole thing was centered around a deadline, which I contend to say is what keeps those programs in line, but that's another story. The whole thing was get it done before the decade, get it done before the decade, get it done before the decade. When does rushing like that in spaceflight ever work? Ever. Never works. They tried that with the shuttle in the 80s. Didn't work very well. Am I wrong? You need a careful and considered approach with spaceflight. And that makes the Apollo missions even more ridiculous. The fact that we just crapped out a lunar program in less than a decade, albeit with a blank check from Uncle Sam, right? The fact that we just pooped out one in less than a decade is ridiculous. It just shows how ballsy those missions actually were, and they made it look damn easy. But higher risk, higher reward. Always. Chain smoking and lots of coffee helped. Bingo. Oh yeah, Silver. Spaceflight is... I think it's safe to say that I like this stuff. Keeps me going, man, The blank check helped, but the funny thing is, yeah, absolutely, Astro, but it's very clear that, money, a blank check isn't the only thing here. NASA's budget is gigantic. It's huge. That tells me two things. The blank check wasn't that big of a factor because NASA's budget is gigantic. It's bigger than every other space program in the world combined, and probably even the commercial entities as well. Right? NASA's budget is somewhere in the order of like $25 billion a year. Billion, B. And that's a drop in the bucket for Uncle Sam, which is kind of nuts, right? But even with that, that's still a bigger budget than everybody else. I don't think money is a problem. I think it's a programmatic thing. And once again, that just shows how ridiculous the Apollo program actually was. Ryo, I agree with you. It was bananas that we just crap that out, no problem. Yeah, we can land on the moon. Do we know how to land on the moon? No, we'll figure it out. Let's go. Hey, Jeff, the minds that put it together. Yeah, freaking credible. It's astonishing, even 52 years later. Crazy, right? Go to sleep? Frick that, dude. I'm running on adrenaline, man. We good. Let's see. What time is it? It's 8:16 p.m. No problem, Ryo. Adrenaline and how many toothpicks? Oops. I'm good. I'm fine. We're good. We're okay. Hey, I'm a big guy. It takes a lot of caffeine, alright? What the heck is in those toothpicks? Sucralose, xylitol, caffeine, B6, and B12. Nicotine. No, there's no nicotine in them. Bless your overworked heart. What the frick? Boomsticks. Oh yeah, dude, they brought me right around, man. I'm good. Well, we're gonna be paying for this one later. If I'm a little late to the stream tomorrow, you know what happened. Will you get some sleep over the weekend at least? Always do. Want to buy some death sticks? I don't want to buy your death sticks. You don't want to buy my death sticks. You're going to go home and rethink your life. I'm going to go home and rethink my life. Did you see the interior progress on the Artemis 2 capsule? Yep. Looks like I picked the wrong week to quit juiced toothpicks. This is just a playlist, Dadu. Did you see the cone, RJ? Oh, I saw the cone, man. Absolutely. All right, Neurobot. Thanks for the coverage. You're absolutely welcome. Thank you for watching. Looks like I picked the wrong week to stop measuring stuff in bananas. What brand are them toothpicks? They're called Energy. Yeah, they're Marlboro. Marlboro toothpick. EJ's Marlboro, man. Don't smoke. It's bad for you. With that being said, if you understand that it's bad for you, have at it. You shouldn't do it. And I think even people that smoke would say that. Do you smoke? Do you smoke? Oh, man, what are you doing, man? It seems like Madrid 63 switched over to Voyager 1. Configuring for Voyager 1. Yep, they moved the dish. Deploy the dish. No, it is too early. I am not ready. Do it. Spike them. Come on, Boris. No way. Spike them. The chief of computers will call me a genius, move me to Moscow, and give me $1 million hard currency. I think not. Besides, the Americans are slugheads. They'll never detect me. Nobody screws with Boris Grishenko. I am invincible! Chat, was it good for you too? Don't mind me, I just haven't slept in a little while. I don't know if you could tell. You sit on it, but you can't take it with you. For real, Balbon. Frozen. It's energy. Toothpick for men. Menergy. Jeff, you just got off at 12? Yeah. That's my shifts, dude. 10 to 12, 5 days a week, Monday through Friday. Been doing it for a decade, man. I've been coming to the same party for the last 10 years. And that is in no way sad. The toothpicks are laced with caffeine, MotoKid, yeah. Yeah, I had not been introduced to these things until Brimo brought them to me right before the landing when I was tired. And B6 and B12. It's got vitamins. Oh, moving the mouse. Stop moving the mouse around. Yeah, me neither, Ivo, until now. They work. I can attest to that. So your wife brought you drugs. It's the reason I put a ring on it, Panta. Just saying. Brimo and she's Brimo's linking the link to the toothpicks in chat. You're smoking that thing like you're an ex-smoker. No, never do that. Carrot smoking's bad. Okay, you shouldn't smoke. Okay, drugs are bad. Shouldn't do drugs. This has all been grape weather, guy. I mean, dude, it woke me up. I mean, I was chomping on these things, dude. I needed to get all the caffeine. And drugs are bad. You shouldn't do drugs. Drugs are bad, okay? Heck, you smoke weed every day. You shouldn't do weed. Weed is bad, okay? You shouldn't do weed. That is a toothpick. Very observant. Okay. Now, attention students, we're gonna all sit here very patiently, okay? And what we're gonna do is wait for the signal, okay? I got like a recommended usage, don't OD on caffeine. Oh, we're way past that, Jerry. Signal is weak, Frankie. We would see a stripe. Give me a second. We'd see a stripe like that. Right around 2210.59. And this should be a solid block. They had a weak signal from the thing, and then we haven't really seen anything since. This is a live stream of that. This is AMSAT DL. Satelliten für Kommunikation, Wissenschaft und Bildung, Satellites for Communication, Science and Education. Yeah, it's good, yeah? Show what it would look like. Tell me what to do. You're not my dad. You ain't my dad. That's what it should look like. That's a strong signal. This means everything is good. We got that. And then nothing. That was about an hour ago. About 50 minutes ago. And then, since then, it's been silence. We should be looking right around here. This is where we're looking. What these stripes are, and I just learned this, I'm not going to lie to you. This is background noise. You're looking for stuff like this. But a continuous stripe. That means communication on a certain frequency. This is frequency over time. This is your frequency over time here. That's your frequency this way. Just straight frequency. And I'll be honest, I don't know what the decibels are about. Decibels, as far as I know, up until this point, were about sound. But, I mean, radio waves make sound, so. Decibels are strength. There you go. You can see it if you scrub back. Amplitude and strength of signal. And okay, all right. Let's see. Let me test my knowledge here. If the amplitude, oh shit. If the amplitude's bigger, it's stronger, right? If you have a higher amplitude. You're looking at me like that. New tweet confirmed. From who? Amplitude is more power. Hell yeah. Tweet from Intuitive Machines. After troubleshooting communications, flight controllers have confirmed Odysseus is upright and starting to send data. Right now we are working to downlink the first images from the lunar surface. Yeah, guys, that roll, the roll component, antenna was pointed in the wrong direction. That little roll component. And think about this for a second. We're about 1 hour out from the weak signal, right? And we know that it was changing on the signals were changing on 15-minute intervals, which means they've tried 3 different combinations, and they got a lock exactly, well, not exactly, but close to an hour later. Which means it just needed to switch the antennas. Just needed to switch the combination of antennas. I suppose it's time to celebrate, huh? Cheers, guys, to the first lunar landing in 52 years for the U.S.
Discovery, go at throttle up.
It's pretty good. Whiskey, Tessa. This is
go at throttle up.
Knob Creek. That will put hair on your LOX tank. Took you long enough. I was waiting for Intuitive or somebody to post something. Caffeine and alcohol, bro. You don't know me, okay? You don't know me. Did we get anything? We got confirmation from Intuitive there. Now you can't drive home. Ah, crap. My commute sucks. It takes forever. There's always traffic. Somebody, there's always cars in the way. Damn internet traffic, yeah. Yep, so, once again, I don't know if my theory was right, but it seems that it's, you know, the second for it to take, the second for them to get an established signal on a 15-minute interval, when Intuitive Machines said that there's 4 antennas on the top, all pointed in different directions, and that Odysseus would cycle the different antennas on a 15-minute interval, and they got a lock an hour later. That certainly seems like what I said was right, coupled with the fact that they said that there was a roll rate during landing. The antennas were pointed in the wrong direction. Easy peasy. First U.S. soft landing on the moon in 52 years, baby. 52 years. The frick took us so long, man. When was the last garage stream? I've not been around for a little while. It's been a little bit ago, Moto Kid. You want to see something cool? Here, real quick, real quick. Oh, you can't tell from this angle. I turned the 97 around. The 97's white. Yeah, I got most of the spray paint off. I turned it around so I could get all the spray paint off the doors. Oh, and Freb runs, by the way. Yeah, it runs and drives. I just have the covers on them so I don't get stuff on the hood of the car. Are you going to play today? I appreciate you explaining space. Just asking to know what to expect. Dadu, I already played a little bit of Workers, dude. So, guys, I've been burning the candle at both ends this week. So, Dadu, I'm probably going to take a break. And then I have a meeting also that I have to do. But I'll be back for the Starlink launch at 11. And yeah, we'll resume Workers tomorrow. I think tomorrow will be the last day for Spaghetzov. I think I'm ready to close the book on Spaghetzov. We will start Gnocchi Grad next week. Greg, you got a project car? A 69 two-door Escort. Very nice. Very nice, bud. All good, my brother. Yeah, I'm gonna take a quick cat nap, dude. Yeah, Zay, that little roll component, the antenna's pointed in the wrong direction. I'm pretty dang sure. I'm like 60% sure. And when EJ's 60% sure, 60% of the time, he's sure. Every time. Gnocchi Grad! That's the name of the next city that we're going to make in Workers and Resources, Soviet Republic. Have you studied for NASA Spaceflight Live? What's NSA and Space Flight Friday Nights Journey? I don't know what that means. Are you talking about NASA Spaceflight Live? Because if so, then yeah, oh yeah. Didn't crash, no. This is why in Kerbal we put communication satellites in orbit around the moon. NASA Spaceflight, yeah, and NASA Spaceflight Live starts tomorrow on this stream at 7 p.m. Eastern. So they're confident that the module is not on its side. I don't think they would tweet that it's upright if they weren't, my dude. Are you familiar with model predictive control? This is what will be used in future autonomous landers in some cases. I've heard the words before, Astro, but I don't know what it is off the top of my head. I've heard someone say those. Those words have come out of somebody's mouth, and I was there at some point in time. Now, as to what it does, it's probably some type of predictive algorithm for landings, if I had to guess. It's just given the situation. Am I wrong? I don't know. You tell me. Hey, my dad and his buddies are watching. What's going on, guys? That's pretty cool, right? That's pretty neat. Just saying, that's pretty cool. Just found out Eagle Chem, if it was deployed, was the first lander since 1972. Not powered though. Not a powered descent though, Zay, but yeah. Hi, EJ's dad. Papa EJ, what's going on, guys? He's watching with his buddies. That's pretty damn cool, man. What's the next Clips mission? Viper? Viper mission, I think, is the next one. What's his stream? He doesn't stream. Does he look like he knows what a stream is? He just wants a picture of a goddamn hot dog. Astro, you're hoping to work on the next Eagle Cam if I can get into ERAL. Right on. IM-2 and then IM-3 and then Viper? Well, the more the merrier. You know what? Give me another one. Give me another one. First soft landing in 52 years. Give me some whiskey. Neat, dog. Prost. Salud. Na zdrowie. Damn, that's tasty. Drink's bad. Okay? You shouldn't drink. Drink is bad, okay? Thanks, Geek. Love you too, buddy. Just one more shot, bro. Please, please, bro. Please. Please, I'm not an alcoholic, bro. Just one more shot, bro. Please, please. It'll fix everything, bro. Please, just one more shot and then I'm done. Or as I say, nice driveway. Thank you. I like my driveway. Anything on the DSN? Nope. Floor stream incoming? Bro, it's 2 shots. That does nothing. That does nothing. Anything from AMSAT? Nope. Anything from the AMSAT stream? Oh, this is from 3 hours ago. What music are you listening to? It's just background music. The MSAT stream moderator went to bed. Yeah. Are they sending, my dad asks, are they sending back any data? Intuitive Machines has a lock on it, and they would be locking on with Goonhilly, or I think AMSAT is just monitoring what's going on. That's why I'm kind of sitting here looking around to see if we can see who's locked on. There's Scott doing his thing. But we got nothing from Goonhilly here, but from Intuitive Machines, because they're using Goonhilly's tracking dishes to get a signal lock. But the company themselves says they got a lock, and the thing is upright and sending data. So they're downlinking images right now. Goonhilly, that's the best they could come up with. That's a place in the. Goonhilly's bad. You shouldn't name your place as Goonhilly, okay? Cracking open the cold. Wait, what? Jeez. Goonhilly's bad. You shouldn't Goonhilly. What's it named after? Really? I was just saying it's a region in the United Kingdom. It's in the southwest part of England. Goonhilly's bad, okay? You shouldn't go to Cornwall. You should go to Cotswolds instead, okay? Yeah, Cotswolds. You should go there instead. I bet you English people are watching the stream right now going, how the hell does he know where that is? How do you know what that... Well, I know, all right? I've watched Clarkson's Farm, okay? Okay. Okay. You had no clue. Now you want to make fun of the southwest of the United Kingdom for Goonhillying. The region that Goonhilly is in is called Cornwall. Well, Cornwall is close, but yeah. Give you 3 guesses what they did there. Oh! Madrid 54. Come on, get a lock, baby! Get a lock, baby! How long does a signal from Voyager 1 take to get back to Earth? A minute. Figuratively, not actually a minute. It's a lot longer than that. I don't know what it is off the top of my head. It's a long time. They built walls of corn? Yeah, how'd you know? Wow, are you psychic? They did so much training in Cornwall. Nice. Yeah, 26 hours. Takes a little bit. LND-1 is Lunar Node 1. Lunar Node 1 is a NASA payload that's on the Odysseus lander. It says right on the graphic. Well, there you go. Round trip, 1.8 days. Well, look at how observant you are, Pravis. I'm just kidding, man. Thank you. Yeah. Sorry, my brain. I'm not firing on all cylinders right now. I haven't slept in a little while, and I just decided to do a couple of shots there. Not saying I'm completely gone, but it's more tiredness than liquorness. That didn't make any sense, but you absolutely understood what I said. Don't lie. Kowalski, analysis. Enhance. 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 I didn't know you watched Clarkson's Farm. You enjoy it? Yeah. Yeah, it's pretty... Spaceman, from what I can tell, and I know, you know, I know Jeremy Clarkson, dude. I've been watching Grand Tour I've been watching since it came out, and then Top Gear before that, before they decided to take Top Gear off the air after Richard, Jeremy, and James left, and they promptly never played it again after that. Yeah, I've been watching Top Gear since 2008, dude. First episode of Top Gear I ever watched was the one in Japan, where Jeremy's in the GTR racing against the Japanese trains with Richard and James. That was my first Top Gear episode. Can you believe that? But yeah, so I know about Jeremy, but farming is cool, man. It's cool. A lot of science, a lot of engineering involved. It's you know, pretty damn cool because, I mean, considering that, you know, I mean, one, those, you know, farmers are the people that feed you. That's kind of important. You should keep that in perspective, right? But two, the science behind it and how you measure like moisture content for wheat and stuff in order to figure out the right time of harvest. That's super cool. Yeah, super interesting. I never would have known, dude. I'm not from the sticks, man. I'm from the city, dude. I don't know nothing about that. Little detail on the SpaceX 7. Oh. Look at the engine. At certain angles, it becomes visible. Oh, that's killer. Blacked out SpaceX logo. I was unpacking boxes. What are the updates on the mission, Hypersonic? Well, this thing and this thing wouldn't suggest anything, but that would suggest something. Sure. He loves us. Yeah. Oh, yeah, Voyager 1. Yeah, Phil. Voyager 1 is, easy broke. I'd say it ran its course. That is a very cool tweet. I just got a text from my mom. What does it say? Time for bed, my son. Oh, but Mom! I'm hanging out with my friends. Mom! But Ma'am, I have to see the intuitive lander pictures before everybody else does, or else people won't think I'm cool. But Ma'am, I have to get the first one, and people won't think I'm cool. Yeah, I got called out. I should. Yeah, I mean, you don't want to piss my mom off. That's Italian lady. It's not a good idea, dude. Not a good idea. Let's pack it in. We should probably leave now. Okay, yeah. I gotta sleep so I could go to school in the morning. No. Okay. So, fellas, I'm gonna go take a quick cat nap. Congratulations to Intuitive Machines. Awesome. Awesome stuff. First soft landing in 52 years. Very, very cool. The future is now, old man. It sucks that we didn't get more streaming coverage from them. But yeah, either way, I'm going to go take a quick cat nap. I will be back I'm serious. I'll be back in 2 hours and change, give or take, for Starlink. And if I'm not back in 2 hours and change for Starlink, that means I probably fell asleep and didn't wake back up. So, if you're watching this in the future and go look at VODs and the next VOD is, 12 hours from when this one ends, well, you know what happened. If I don't see you a little later tonight for the Starlink launch, I'll see you guys tomorrow at noontime. We'll get back into playing Workers and Resources. So tomorrow, we got games for about 7 hours, and then after that, it's NASA Spaceflight Live with my buddies over at NASA Spaceflight. Don't worry, that's being streamed here. And then after that, I don't know. Who knows? Who knows? We're all gonna have a lot of fun, right? Tomorrow is Friday in California. Shoot! So, thank you for enjoying this coverage with me. I do appreciate it, guys. And I appreciate it very much. Thank you for all the support, and I'm glad we could enjoy it together. It means a lot. Hope you enjoyed my piss poor commentary. And yeah, I'll see you guys later. Thank you very much for watching. Have a good night, okay? Or I'll see you for Starlink in 2 or 3 hours. I'm gonna fall asleep. I'll try. No guarantees, dudes. Okay, I'll try. Anyway, night or see you in a couple hours. Either way, enjoy, and thank you.